Yo, what's good, people? It's Iversile here with my first ever video. Pretty excited to get into this. I noticed a lot of Roblox scripting tutorials nowadays are kind of outdated. So I thought, you know what? I think it's about time. It's about time somebody updated the scripting scene. And why don't I do it myself? So this is going to be a pretty long series, I'm presuming. I don't think I will stop it for any particular reason. It's going to go for a while. For a while, because I do want to cover a lot of more advanced topics to help. Because back when I was learning to script, I never got any advanced help with scripting and developing frameworks and different methods of scripting. I never really got in-depth tutorials of how to do that stuff. I kind of had to figure it out by myself, and that took a lot of time. It would have been a lot better if I just had a layout, that somebody who was experienced kind of already knew already to teach me how to do these things. But nevertheless, sit back. Aversal is here to drop some wisdom bombs here. But seriously, welcome aboard. In this video, I'm just going to be introducing the concept of a script because after all, this is a scripting tutorial, a scripting series. So it's probably going to involve a lot of scripts. But before I talk about scripts, I think it's important how we approach scripting because scripting can be seen as this hard topic or, there's a certain way you have to do something or even what you need to know. This was a personal thing with me is I thought I had to know everything about every single detail. And that really just isn't the case. The point of scripting is to give you a set of tools to help you build your game. That's fundamentally all it is. But I would often find myself wondering, like, okay, well, why does this work? What are the specific features of this function or this or this or this? And really, you just need to know how it works, why it works, just the surface layer. You don't need to go so into detail unless you're like somebody who's into that. I can understand that. But we need to take this in steps. There are certain things that I am going to obfuscate for a certain amount of time until it becomes relevant, right? Because I think the best way to learn how to script is to just pick stuff up as we go. I want to do this thing, and therefore this thing is going to be very useful to us in scripting. So I don't want you to have a fearful mindset or this feeling like you have to know every single aspect of everything. It's a never ending journey of learning. So please don't be nervous about any of this stuff. Any of the stuff I'm going to show you, please just trust me, listen to what I have to say, do what I do, and eventually, maybe 5, 10, 15, 20 episodes later, everything will just click. There's only so much intuition that you can have about each topic I'm going to talk about until it just comes down to muscle memory. So, we all good? We're all good. All right. Let's go ahead and just open up a base plate here. I'm going to presume you already know about Roblox Studio. If you don't, I'm going to link a video in the description. Go watch that, then come back, and we're going to get right into it. So, first thing we're going to do is we're going to right click on this little service called a server script service. Now, once again, as I said, you don't need to immediately understand intuitively what a service is. But let me give you just a brief idea of what it is. I'll give you some surface level intuition. Basically, a service is the services are like the organs of the game. And the game is really just the game that you make. So if I highlight all of this stuff, all of these services in the Explorer, these are sort of our primary services. And these primary services are the main organs of the game. So I think for now, that's all you really need to think of it as. Server script service is basically a service that lets you put server scripts in them or in it. And a server script is going to look like this. It's going to have a little piece of paper with some drawing, and it's going to say script. Make sure it does not say module script or local script. It should say script. Click, and we opened up our first script. Now, do not worry, you do not need to know what a server script is, but you might be wondering, what is this print hello world statement? What is that? Well, let's go ahead and delete it. Let's just cross that and then backspace. Deleted. Now, I presume you should know how to run your game. Let's click on that. And you're going to have this little, if you don't have this window, output, I'm just going to exit out of it. Go to view, and then click on this button here, output. And I presume you already have Explorer and Properties open because obviously like you need those two open. But you notice all this jargon kind of came in here, blah, 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 blah. None of this matters, okay? That's not the point. We're going to stop the game. So now you have output open. Let's go ahead and write that statement that we got when we first opened the script. So hello, print hello world. I think it was this, right? I think so. Well, actually, let's just delete this so you can cut it. Right click, cut it. Right click, insert object, script. And you see we get the same thing. So every time you open a script, or sorry, every time you create a script, you insert it into the server script service or wherever. I recommend you only put server scripts in the server script service because that's the most secure way of creating scripts, and I will explain that in a very later episode. But let's just remember, just pound it in your head. Always put server scripts in the server script service. Always do that. Always remember to do that. And for now, the answer I will give you is it is the most secure way of creating server scripts. And once again, you also don't need to know what a server script is. That's fine. But either way, every time you create a script, it's going to have this little print hello world statement. And we're going to go ahead and just click inside of these double parentheses here. And you can see it explains to us how all this works. Print string blah, 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 blah. So it says it prints all provided values to the output, any number of arguments to be outputted. So you notice it says prints all provided values to the output. The output. Oh, whoopsie. Hold up. Okay, there. The output. This is the output window. So how is it going to print out? Well, let's see. Let's run the game. What's different? Let's see. Wait, do you see that? Hello world. Let's click on it. It takes us back to our script. So you're probably wondering, what is the output? The output is kind of like a messaging helper of sorts. And it basically interacts with your scripts and prints out any information that's important. And there are different types of messages from scripts that can be printed out. But just take keyword takes information from scripts and prints it out. But you have to explicitly put it in a print statement. Hence why I said it prints it out, but you have to put it in a print statement in your script. And we can see once again it says prints all provided values to the output. So you're probably wondering, what exactly is this format? The way that I wrote this, okay, I understand what this does. It prints out this hello world into the output. But you're probably wondering, why doesn't it print out these? Why doesn't it print out the brackets? Why doesn't it print out any of that stuff? And it's because of the format syntax. Syntax is kind of like the language that we're using to describe what we want to do. Because coding isn't just English. I'm sure you figured that out by now because this might not make any sense. And that's fine. You don't need to understand it. Let's break it down. But first, let me show you something. So make sure that you have two double quotation marks, right? These two here. Make sure it looks like mine. And you'll notice if I type out pizza, for instance, and I click run, look what it prints out in my output. Pizza. Okay, let me give you a more practical example. Let me say this script isn't working. This script is not working. We're not getting what we need. Oh, I got it. The script isn't working. Okay, where is it? Oh, I click on it and it opens the script. That's a practical example, and we're gonna have to do that later on, and I'm gonna show you how later. But that's kind of like an introduction to a later episode. So let's get into data types. There are three main data types I want to introduce now. If I don't know, three, four, I don't know, but let's write some stuff down here. So the first one we've already seen, which is a string, right? And you know this because it prints right here. Now let's say I just erase everything in here and I put the number 5. It's not string anymore, it's number. So I've just shown you two data types, a string and a number. A string is just text, essentially. That's all it is. But you have to put it in between double quotations, like a quote, right? I'm quoting Mark. He said, I like pie. I don't know. But yeah, you get the point. Double quotations indicate a string. No double quotations and just a number indicates a number data type. And if you think about it, it's just a type of data. Data can be stored as a number, it can be stored as a string, which is just text. That's how Roblox works. And you're going to see why these types of data are more useful when you get more experienced. For now, you just need to know, just get this in your head, because these things are going to be very useful to you in your later in your scripting journey. Oh yeah, and I also never printed out a number yet. So let's print that out. And you can see right here, printed it out. 53425, 53425. So that's neat. We can print out strings or text, and we can print out numbers. Well, what else can we do with this? Well, let me tell you something cool. You can actually do math with printing. But you might be wondering, why is this formatted like this? Why are there brackets here? Those brackets are going to be common in what are called functions. And inside of these parentheses are what are called arguments, which are just the things that you want to be done with the function, which is print. Now, obviously, you don't need to know what a function is right now because we're not talking about functions. I will go over that explicitly in a separate video. But specifically, what this function is it's called a variadic function. And I will go over this explicitly in a separate video. Now, I'll also bring up print in that video so you kind of fully get the intuition for what print is. However, this is of course the first video you're watching on scripting. I am not going to ever expect you to know what any of these things are. I'm just giving you basic information so that maybe if you want to research on your own a little, when I bring up stuff like keywords that you might not understand, that's kind of me hinting that like you can go research it yourself, but really you don't have to worry about it because I'm going to explicitly tell you what that is later on when it becomes useful. But either way, just know that out of all of that esoteric gibberish, the point is you can put any amount of arguments. Remember, arguments, I said, were just the thing that you want to be done with the function, which is print. And you might ask, what does that look like? Well, let's write a string. Remember, double quotations, hello. And if we run, and we click on run here, and it loads, we will get the text hello in the output. Ain't that cool? Let's stop. Let's go back to our script. Let's add another argument. Because hello is an argument. Let's add another argument. Put a comma. Put a space. Now let's put the number 8. What do you think is going to happen? Well, let's find out. Let's go. Wouldn't you know it? Hello, 8. But you might be asking me, well, actually, I know you're asking me, why is there a space between hello and 8? Well, I'm going to explain that. So, first of all, I want you to know why this might be useful. Let's say let's say you want to print out a string and a number in the same print. Well, I can do this, print 5. Well, there you go. I just printed hello and 5 separately, and let's run this. And you can see they occur one after the other. So hello runs first, 5 runs next, and you might wonder why. And I'll tell you why. It's because hello is on the first line, whereas print 5 is on the second line. So whatever, it goes top to bottom for this sort of stuff. And you can also see that right here. So script 1, script 2, that means the line. And this is the name of the script. Okay, sorry, I had to do something for a minute. I'm back. But as far as I remember, we were talking about script 1, script 2, which means, okay, this is the name of the script. This is the line that the thing above it, was executed. Look, script 2, 5. Line 2 of script printed 5. That's correct. Now let's just rename our script. So click on it, make sure it's blue, then click the name itself, and it'll open this little thing where you can kind of type it. Let's say Bob. Okay, and if you couldn't do that, just right click it, go to rename, and then it'll do the same thing. So let's run this again. Let's run it, and look what we get. Bob 2, Bob, Bob 1. And if we click on the statement itself, it leads us to the line that it was printed on. So if I click 5, it goes to the second line. So that's pretty cool. That's what the output, that's a nice feature of the output. So let's go back into Bob here. Now let's say I wanted to print this on the same line. Maybe I want it to be neat, or maybe I want it to present itself a certain way. So let's just get rid of this, because we want to do it on the same line. And if I remember correctly, I already showed you this comma, which means we're going to add another argument, and we're going to put 5. 5 is, sorry, hello, this string is the first argument. 5 is the second argument. An argument is something that we are going to print out in this specific print function. The comma separates each argument, so each thing that we're going to print out, with a space. So when we run this, we're going to get hello space 5. You're probably wondering, how do I do it without a 5? That doesn't make any sense. What if I didn't want a space there? Well, that's fine. You don't have to do that. There's another way, and this is what's called concatenation. Concatenation basically just connects two arguments together without a space. And you'll see when I print this, it's going to print hello and then 5, but there's no space. So that's how you can connect two things. Because I mean, otherwise, there's not really any way you can just write 5. Like, you can't just do this. That's incorrect. That's incorrect syntax, which is the language we're using. This is not how the language works. You want to include two data types. Well, then you have to either concatenate, which is 2 dots. So let's say hello dot dot 5. And concatenate, like I said, connects two arguments. So two things that we're going to print, but it doesn't put a space between them. And if you're clever, you might have realized there is still a way to put a space between these two. How do you do it? Well, you make a space in the string. And you'll see that if I run this like this, it's actually just going to make a space at the end of our string, and then we print 5 without a space. But since there's already a space there, sorry, I didn't click run there, it's going to have a space. Hello, 5. I have had instances where I had to connect a string with another data type. So that is important to know. So concatenating just means you're connecting two arguments or two things that you're going to print, but it doesn't put a space between them, as long as you don't have a space in your string. And then obviously I made the other example of just making two separate arguments with a comma. The comma basically separates two arguments, so two things you're going to print. And I'll keep saying that over and over again, okay? You got to get this drilled in your head. An argument is just the thing that you are going to print in this specific function, the print function, okay? And we're going to talk about functions later. Don't worry. But just drill that in your head. That is what an argument is. It's just the thing that you're going to print. So we're going to print hello. Let's say we want another argument. Well, if you want two data types, you have to separate them, either with concatenation, which is the dot dot, or by putting a comma. And always remember that concatenating does not put a space between your two data types, whereas comma puts a space between your two arguments, the two things you're going to print. You might be wondering, well, these arguments, how many arguments can I have? You can have as many as you want. I could print 1, 2, hello. I could print pizza. Sorry about that. I could print 56. I could print as many as you want, and the list goes on, dot, dot, dot. And so, if I predict correctly, all of these should have spaces between them, and they will all be in the same line. And there you go. 1, 2, hello, pizza 56, all on line 1. So now you should know kind of what an argument is. It's just the thing that you want to print out with this print function. I don't really know what else to call it for now because you don't know what a function is, like print statement, the print statement. And by statement, I just mean whatever is inside of this. All of this stuff combined is called the statement, basically the thing that you're printing. I'll just call it that for now because I mean, saying print function might make it a little more confusing. So we'll say the print statement. And statement, once again, just means whatever I put in here. So let's say I put hello, oh my lord. Okay, 3, 5, Bob. Hello, 3, 5, Bob. That is the statement. Whatever is in between these parentheses, that is the statement. We have a print statement. Hopefully that makes a little more sense. So, I should know what an argument is. It's the thing that you're trying to print. You can have as many arguments as you want in a print statement. So we have hello. So 1, then we have a comma. So 2, another comma, 3, another comma, 4. Comma is how you know you have more than one argument. Well, unless you put it in another statement. So let's say I have a comma in this print statement. Hello, my name is Abersile. Well, obviously that's the same argument. But if you have it outside of this double quotations, well, we just have a regular comma here, which indicates that we're going to the next argument. So we have 1, comma, 2, comma, 3, comma, 4 arguments. We have 4 arguments. So 4 things we're going to print. And I should clarify, when you concatenate, which means you connect two data types. So if I say hello dot dot 5, this is one argument because you still have to put a comma to separate the next thing. Oh, don't worry about what that means. Okay, dude, I swear I did not mean to type that. Like, I just put 3 random letters into my keyboard and that just happened to be what I wrote. I swear, dude. But either way, so concatenating does not make more than one argument. This is all one argument. But once you see the comma and you go to the next thing, that is what indicates the next argument. So either way, now you know what a string is. You know what a number is. You know what an argument is. You know what a print statement is. You know what a print statement does. You know what concatenation is. You know what the comma does. So once you've reviewed all of that information, that is all I want you to know. Okay, this variadic function, all this crap, you do not need to know that. You don't need to know any of that. I just want you to get familiar with the syntax. Oh yeah, that's another word you should learn, syntax. In the most simple way, syntax is just the language that we're using when we code. That's all it is. That's all you need to write down if you're writing down notes. You can write down notes if you want, you don't have to. But there is one last thing I want to talk about before I end this video. Good job if you've made it this far. I'm sorry if I fried your brain. If not, good job. Keep following. But I hope this isn't too overwhelming. I hope this is making sense. I'm going to explain a lot more next video. We're going to get into a lot of different stuff. We're just going to explain a lot of this stuff that I've talked about. Like, once again, it doesn't have to be solidified. Of course it doesn't. It is going to take time. Now, let me stop holding you up. We're going to get to the last topic, and we're going to talk about arithmetic. I'm going to assume you know what arithmetic is. It's basically adding, subtracting, multiplying, and dividing. So I'm only going to use those 4. There are other math operators that you can use in scripting, but I'm not going to go over those. Those are more advanced in relation to what we're doing anyway. And I will cover those in another video. But we're going to stick to those main 4, so adding, subtracting, multiplying, division. You might be asking, what can I do in this print statement, and how does that relate to the math? Well, let's do 2 plus 2. We're adding numbers, so we're going to use a number data type. And you know it's a number data type because it doesn't have quotations around it. And often, I don't know if this is going to be the case for you, but number data types and string data types are going to be different color. So you can see on mine it's green, and then the orange is the number data type. This will probably not be the case for you. I don't know if it will be, maybe it will be, but those colors actually indicate what they are. Like for instance, if I write 2 plus 2 here, it's green, but here it's orange. And the plus symbol is white or gray. I don't know exactly what it is. But that indicates we're actually adding. 2 plus 2 as a string, what do you think that would print out? Well, let's click run. Let's click run. So we have two arguments. 2 plus 2 and it's 2 plus 2 as a string. So you could see that in the first argument, we did 2 plus 2, comma, so next argument, string, 2 plus 2. So you can see, remember when we put a comma, it puts a space between the first argument and the second argument. So the first argument is 2 plus 2. We get 4. Isn't that interesting? We can do math with our print statements. But then we go to the string. It literally prints out the string 2 plus 2, or the text, sorry. So don't confuse that. It's actually going to print out exactly what you write. It is not going to do the math. You have to do it in the syntax, using the syntax, which is just the language that defines the code and how everything works, basically. So let's stop and let's just do subtraction. So we can do 2 minus 2. What do you think that's going to be? I'm going to leave it to your imagination. Of course, it's 0. Then let's do multiplying. I think this should kind of make sense, but I'm just going to do it anyway. The multiplying is the star, which is Shift 8 on your keyboard. It should be. We get 2 times 2, which is 4. And then we have 2 divided by 2, which is slash. So 2 slash 2. Of course, it's going to be 1. That is the syntax or the language to describe to do the math. So slash is division, star is multiplication, dash is minus, and shift plus is, or shift equals will give you plus, which is the symbol for addition. So that's how you do all that stuff. And obviously you can do as many terms as you want. So 2 plus 2 plus 2 plus 2 plus 2 times 2, and it'll do all the math in the correct order. So it should give you 2 times 2, 4 plus 2, which is 6, 8, 10, 12, 14. So it should give you 14 if it does PEMDAS, PEDMAS, I don't know, whatever. Whatever it's defined as for you. And obviously, yeah, it gives you 14 because it did it in the PEDMAS, PEMDAS. I don't know, there's so many versions of it. But yeah, it's going to do that. So that is the last thing I'm going to go over, arithmetic. So by now you should know kind of what a print statement is, what you can do with a print statement. You should know what an argument is and what separates arguments. You should know that you should be able to have as many arguments as you want. You should know what a string is, kind of vaguely. I hope you understand what a string is. It's basically just text. You should know what a number is, which is just a number. You should kind of vaguely know what concatenation is, which means you can connect two data types. Oh, and you should have a basic understanding of how to read the output. Most of this stuff is junk. Maybe I've explained that. I don't know. But the only thing that matters is what comes from your script. You have the script name, and then the line that the code was executed on. And then you have the output, the print statement, and that is whatever is inside here. You should know that you should always put your server scripts in the server script service because it is the most secure way of creating your scripts. Your server scripts, which I will get into in a later video, just know you should put it in your server script service. These scripts right here, it should look like that. If it doesn't look like that or have that icon, then it's not a server script. This is a server script. You don't need to know what that is, but just remember, if it has its icon, you should always be putting it in the server script service. So that's all I really expect from you in this video. If you need to do a little practice, like you want to get familiar with print statements and see what kind of wacky stuff you can do with it, If you want to ask me questions, like if you've done anything with print statements and you're kind of confused about something, feel free to comment. I will try to answer everything I can. But that about wraps up this tutorial. I'm really excited to kickstart this journey. We're gonna hopefully be pumping out a lot more scripting tutorials. Gonna try to upload consistently. I hope I can. I hope I did a good job on this. I hope you guys enjoyed this. I hope it helped. Please let me know if something I said did not make sense. There's something that I said that I kind of just assumed you knew, because I don't want to assume that you know anything. I try to let you know if there is stuff that you should know, and like if I say something and you don't get it, I will try to let you know like if it's actually something you need to know or not. But if I really did miss something, please let me know. I appreciate any feedback that I can get so I can help improve. This is my first video. So, but anyways, if you watched to the end, I appreciate it a lot. If you want to subscribe and follow my tutorials, if you want to like the video as well, I would really appreciate that. But thank you guys so much for watching. I hope this helped you out, and I'll catch you all in the next one. Until then, adios. What's good, everybody? Aversal here, back with the second episode of the scripting series. And I'm going to try to jump right into it as quick as possible, but I want to quickly recap what we did in the first episode and just make sure that I've cleared up any possible confusions that you might have from that, because maybe you might have been confused with concatenations or what an argument really is. I'm going to go over everything from start to finish within just a few minutes. If you're really comfortable with everything we did last episode, then you can go ahead and skip to the next chapter in the video. It should be in a timestamp, it should be in the description, if not on the video's actual timeline. But either way, the first thing that we talked about last episode was that everything in this Explorer tab is the organs, or sorry, are the primary organs of the game. In the game, it's just the game that you make, the game that people play. The game is playable because you have all of these things. You need all of these things in order for your game to run properly. Then we inserted a script into the server script service by right-clicking, insert object, script, which is a server script. I did not tell you what a server script was, but I did not require that knowledge of you. The only thing I really told you to remember was that you should always put server scripts or the things with this icon, and it will say script when you first create it, into the server script service. Now, as for the Explorer, that's pretty much all we did, and then we kind of just jumped right into this whole print stuff. Now, I talked about what a string was and what a number was. Those two are what are called data types, and they are useful because we can convey numbers or text that we want to see. But there is a particular way of writing these data types called syntax. Syntax is just the language, the grammar of Lua, the specific version of Lua. I'm not going to get into that, but let's just say it's the grammar of this language that we're speaking to do all the stuff that we did last episode, the stuff we're going to do in the future. That's what it is. Now, when we clicked on this print, we could say it says print string. And we found out that it does that because it auto detects what the argument is. And we said that it prints all provided values to the output, any number of arguments to be outputted. So another thing we found out was what an argument was. An argument is just a factor of our print statement. Hello world is one argument. And we also learned that to make more than one argument, you simply separate two data types with a comma and a space. And then we write the next data type. So I could say hello world banana or something, right? And we have two arguments. We also learned that we can have as many arguments as we want. So I could do comma 5, comma 2, comma hello. And what do you think is the number of arguments in this print statement? Take a guess. I'll give you a couple moments here. All right, so if you guessed 5, you're correct, and I'll show you why. So the first argument is hello world. What data type is that? It's a string. Then we have a comma. So it says, okay, well, now we're going to the next argument. So the next thing we want to print. Oh, and another thing we learned is that when we put a comma between two arguments, there's automatically going to be a space between them when they print out into the output. So what's the second argument? It's a string again, and it's banana. We have a comma. 5, that's a number data type. Another comma. 2, another number data type. Then we have the last one, which is number 5, which is a string data type. So we learned that we can have any number of arguments, and we learned two basic data types, a string and a number. Another thing we learned, which was useful, was concatenation. With concatenation, we can put two dots between two things that we want to print out, and we could do Bob, let's say. And what that's going to do is it's going to, sorry, I've been burping a lot. I don't know why. It's going to print out hello world and then dot dot. It's not going to print that out, but it's going to print hello world Bob. And it's not going to have a space next to the exclamation mark because it's not another argument. It doesn't do the same thing that a comma does. A comma puts a space between two arguments, whereas concatenation is one argument and it doesn't put a space between two data types that you use. So this is just going to print out hello world exclamation mark Bob, and it's going to be right next to the exclamation mark because there isn't a space because it's concatenation. And you can see there, hello world exclamation Bob. And that's how concatenation works. So you could say strings and numbers are part of our syntax. So if I say like print hello, that's not going to know what that is because it's not text. It's just an error. It says, look, unknown global hello. It doesn't know what to interpret this as. So this red line generally means improper syntax. You're not doing something correctly. So if I really wanted to print hello, I would do double exclamation and it would auto insert a string. So it's telling us that we're inserting a string as an argument, and that's going to print hello. And likewise, if I did a number, let's say 63, it's going to auto insert a number because that's the data type that we're printing out. Oh, and I also talked about script 1. So we talked about how to read the output. So this is our print statement. This is our script name, and this is the line after the colon. This is the line that the print statement executed on. Basically where it came from, like what line from what script. So I think that's about it. I believe that's everything I did in the last episode. Once again, I hope that makes sense. But without further ado, we're going to jump straight into today's lesson. And today we're going to talk about something very, very important. And it's called a variable. So let's go ahead and talk about that. So I'm going to open up my script here. So how do we create a variable in our script? Well, the first thing you always write, for the time being, is this word, local. Local, unfortunately, is not something I can explain to you until we get to something called a function. I previously mentioned it in the first episode, but really we're not going to be doing functions for just a little bit. Once we get there, I will bring up local again, and you'll get a better understanding as to why we use local when we create a variable. But for now, just know to dig it in your brain. Always write local before you give the name for a variable. So what do you think comes next? Well, the name, of course. So we're going to name our variable. I'm going to say I want apples. And we're going to set it equal to 5. So how many apples do I have? 5. A variable is just a name after this word local. You always put local, but this name that comes after local is going to be the name of the variable. Equals is what you're going to set this name to. And you can set it to any type of data. Now, that might not make complete sense, but it doesn't really need to because you're going to understand very quickly what you can set a variable to and what you can't. So, cool. We made a variable. We called it apples, and we set that name equal to 5. Well, let's reintroduce our little print statement. So if you remember, it's print And you'll see it pop up actually on your screen, print, and it's gonna be highlighted blue. And if you click enter, it's actually gonna auto complete the syntax for you. So now we can just type in whatever we want. So a string, a number, whatever. What do you think I'm gonna do here? Well, wouldn't you believe it? You can actually insert your variable name into here. So let's try inserting this name into here. If we print apples, you'd say quickly, whoa, wait, that's not correct syntax because that's not a string. And you're right, it's not a string, but we've defined it. That's the difference. If you've defined something, it's just going to be equal to whatever that name is equal to. So if it prints apples, what do you think it's going to print? Do you think it's just going to print apples? No, it's going to print whatever this variable is storing. What is the data that this variable is storing? Apples. It said, well, what's it equal to? 5. So what do you think print apples is going to do? Well, let's run. 5. Wait, we printed apples. Why didn't it print apples? Well, first of all, it's not a string, it's a variable. Otherwise, this would just be wrong. If we didn't define this, you would see that it actually turns red because that's incorrect. Apples is not defined anywhere. See, it doesn't know how to recognize what is apples. I don't know what that is. It's not defined. So I'm going to undo that, and we see it's no longer red because now we've defined apples. And it printed out 5, which is what apples is equal to. So it's pretty cool. We can use names to represent other types of data. And trust me, what I just showed you is going to be saving your life as you learn how to script better, okay? This is such a key aspect that all scripters abide by. Variables are so huge in scripting. You get used to variables, guys. Get used to them. All right, what else can I do as a variable? Well, let's go ahead and stop the game first here. So let's go back to our script and let's change the variable. Let's change the name too. Let's call it text. And I think you probably understand where I'm going with this. I'm gonna create a string. So local text, local is just the thing that we're gonna use. We're gonna keep using that. I'm gonna explain it later. What comes after local is the name of the variable. And this variable is just a name that's going to store a piece of data. And we're gonna set that data equal to whatever type of data you put here. And as you see, double quotations, that indicates a string. Let's just put Bob likes spaghetti. I don't know why I like the name Bob. It's just, I don't know. Anyways, as you can see, there's a syntax error. The script does not like that. Apples is not defined anymore. Why is that? Because the variable isn't called apples anymore. And so, apples is not defined anymore. So let's change that name to text. So it's going to print text. And what do you think it's going to print out? Just imagine you're taking whatever text is equal to and you're just replacing text with whatever the text is equal to. So just imagine moving this string into here. It's essentially the same thing. That's what a variable does. It's a placeholder. That's all it is. So obviously when we click run, we will get Bob likes spaghetti. Great. He loves spaghetti. He really does. So what else can we do? Well, believe it or not, we can do math. And math is going to be another thing that you're going to have to do while you script. So better get used to that. So let's say let's say equation. Let's say it's an equation. Equation is equal to 2 plus 5. Do you see where I'm going with this? Let's go print. Oh, whoopsie. Let's get that back into the proper format. And let's write equation as our variable name, and let's let's put it into our print statement. So it's going to print equation. What do you think is going to happen? Take a guess. You're probably right. Let's go ahead and run. And what do you know? We can do math from a variable. It's crazy. Because all you're doing really is just replacing this with this. That's all there is to it. So that is basically all I really need you to know about variables for this episode. I hope it makes sense. It's just a name that you give some purpose. You give it a piece of data that you want to mess with later. Let's say you have a bunch of code and then you set this initially and then you have a bunch of gibberish, blah, 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 blah. I'm writing code. And then you're like, okay, well now I wanna get back to this equation. Obviously do not write actual code. Um, so now, okay, I think it's time we print our equation. And then it prints. So you can store it and then just use it whenever you want. And that's another thing. You can actually refer to equation by just writing its name, equation. And don't be confused. Think of local as initially defining the variable. And whenever you use it, after it's defined, it is just going to use whatever you stored in this variable name, and it's going to use that. So right now you could say that equation is equal to 7, right? So this would really just be 7. I'm writing 7 basically. Let's say 7 is equal to itself. 7 is equal to 7. That's true. But then let's add 1. What do you think that does? Let's go to the start. We define equation as a variable. The name is equation, and it's equal to 2 plus 5. We can now use it without doing local because we're not defining it, we're just using it to do things with it. So equation is equal to equation, okay, sure, plus 1. What do you think that does? Well, I'll tell you what it does. Let's print equation. Let's see what it does. What did it do? It should be 7, right? Wait, no, it's 8. Why is it 8? Well, let me explain. This is basically making me redefine equation. It's kind of like saying equation is equal to itself, which is 7, plus 1, which is 8. That's essentially what it's doing. It does the same thing, because right here, 2 plus 5 is 7. 7 plus 1 is 8. And if we just did equation, it'd be writing the same thing. So we're not defining it, we're just redefining it. So you can actually change the value of variables, which is also super useful later on. Please remember this. Once again, none of this has to click immediately. This is stuff even a lot of people talk about later, but I think this stuff is just super important, and I want to introduce this stuff to you guys early so that you have better intuition later on. So I know it may seem like I'm kind of hitting you on the head with the hammer quite a bit, really pounding this stuff down on you, but trust me, you don't have to understand all of this. Just get the basic idea. Let it sit in your head for a while, okay? Play around with printing, play around with making variables. Because you can sit here and learn from these tutorials all you want, but at the end of the day, you gotta put in the work and practice to really understand all this stuff and build up that memorization through repetition. So that's pretty much all I really want to do today. It's a little bit of a shorter episode, I think, than yesterday. Because I mean, I was kind of doing a lot of introduction yesterday, so. But variables are pretty quick, like when it comes to just introducing them. Next episode is going to be a big game changer. Like, this is where we're really going to see stuff actually changing in the game. So, I hope you guys are excited. Thank you for sticking through. You've done yourself a service because now, next episode, we're really going to script. Okay, this stuff is all just preparing and figuring out the essentials before we get into what we really need to get into here. So next episode is going to be, let's say, a practical episode. So we're actually going to change stuff in the game. So I hope you guys are excited about that. So yeah, we basically recapped the last episode. Then we talked about what a variable was. We write the keyword local. Then we write the name of the variable. I could say variable 1. And it's going to be equal to any piece of data that you want. So we could do a string, we could do a number, and there are other ways we can store variables, which we will talk about next episode, which is why I'm telling you about them more in a pure sense than a practical sense, because next episode is where you're going to apply variables so that we can do some interesting stuff in game. Oh yeah, and we also talked about lastly that we can actually change the value of our variable. So we could say variable is equal to, well, let's just set it to itself plus 5. And if we print it, it's not going to be 5 anymore. It's going to be itself plus 5 extra because we're redefining it, right? So now it should be 10 when we run. And there you go. So that about wraps it up for variables. Hope this episode makes sense. If you liked the video, please sub, leave a like. If you want to keep following the scripting series, it really means a lot to me. And once again, if you guys have any questions, leave them down in the comments below. I will try to answer as soon as I can. But yeah, until next episode, which I'm really excited about, hope you guys are excited. I will see you guys later. Peace.
Yo, what's good? I'm back. It's Abersile. Welcome back, y'all. Welcome to episode 3 of the scripting series. So today, as promised, I'm going to talk about how we can actually change stuff in the game. So that's going to be pretty cool. Because I know you've been waiting. I mean, this is why you're learning to script in the first place, I assume. I'm sure you're not coding because it looks cool or whatever. I'm assuming you're learning to code so you can get stuff done. Well, it's time. First, of course, I'm going to do a recap of the last episode. So let's go ahead and get into that. So, last episode, we got introduced to variables. And I'm going to go to server script service. I'm going to right click, go to insert object, insert a script. And I'm going to just erase this. And I'm going to define a new variable. So remember, the first word we put is local. Then we put a space, and then we name the variable, and we can name it whatever we want. Within limits, of course. You can't put a number first thing, or else it's going to automatically define it as a number. And you can see that from the orange color. So a proper variable will usually be white or black, or depending on the color of your studio. You can actually edit the colors of everything, but you can see that this is orange, but when I do a proper variable like fg, whatever, fjg, whatever, it's actually white for me. But either way, I'm not going to name it gibberish. I'm going to call it var1. That just means variable 1, and it's going to be equal to 5. So we learned that we can name variables, so we just give it a name, whatever you want to call it, using proper syntax, of course, and you set the variable name equal to some data type or some piece of data. And the current pieces of data that we know about are numbers and strings. So I could set it to 5037. I could set it to hello, my name is Bob. Bet you didn't see that one coming. But either way, we can combine what we learned in last episode and print out our variable. So print var1. And what that's going to do is it's just going to print out var1, whatever var1's equal to in the output. And so it's going to print, hello, my name is Bob. Let's go. So yeah, we go back to the script, print var1. Well, whatever var1's equal to is what we're going to print, which is hello, my name is Bob, which is a string. Now, a cool thing you can do is we can actually do concatenation in two different ways. The first way we can do it is we do dot dot, and then we put another piece of data. So I'm going to do another string. And then I'm going to do an exclamation mark, like that. What do you think that's going to do? Well, if you paid attention in the first episode, and I did do a recap in the second episode, but if you paid attention, you'll know that basically this just combines these two without a space between them. That's what it does. Now remember, the argument thing we talked about, that only applies to functions. And once again, I haven't talked about that yet, but I'll give you a little hint. It has to do with these parentheses. See, this here, this is common syntax or the language and how we define functions. So once again, you don't need to know what a function is, but just know that concatenation can occur, but we can't just put a comma. Like this isn't it's not print. We're not printing. It's not the same thing. We're just talking about concatenation. And basically, it combines two pieces of data, but it doesn't put a space between them. So when we print var1, let's see what it prints. Hello, my name is Bob. Concatenate to exclamation mark. And there we go. It's right beside it. Right beside Bob. Let's go. So let me show you another trick. Pretty cool. Well, if you know the fact that, let's just erase this. Well, if you know the fact that var1 is just equal to this string, it's the same thing as just putting this string in here. And so we don't have to concatenate up here. We can just concatenate down here. Dot dot, exclamation mark. It's the same thing. That's the second way to do it. And it's going to print the same thing. There we go. Hello, my name is Bob. I had to yell there a little bit because, obviously I was exclaiming it. So that's pretty much what we covered. We also talked about how we can change the value of a variable later on. We don't have to put local because we're redefining it. When you initially define it, you have to put local. But when you're using this variable at any other point and you're setting it equal to something else, you don't have to put local because it's already defined. Now, listen, I know someone's going to try this. Someone's going to type var1 plus 5. Think about it for a second. Is this going to work? Well, if you have any sense, you know we're actually going to get something red here. Oh, before. So, this red thing, I don't think I've ever showed you guys an error before, but basically, if you do something that isn't syntactically correct, so basically you're not using proper language that the computer can understand, it's gonna say, okay, I don't understand what you're trying to do here. So it's gonna tell you the location, so server script service, script, so server script service, script, 2. So that's the line that the error occurred on. Then, after that, we get an explanation of what happened. And the computer tells us, attempt to perform arithmetic, add on a string and a number. Well, what's var1? It's a string. What's this? A number. You cannot add a string to a number. Okay, that's just not possible. However, if var1 was also a number, well, let's stop really quickly here. If var1 was also a number, let's say it's 6. Local var1 equals 6. var1 is equal to var1 plus 5. So we're redefining it, and we're going to set it equal to itself, but we're going to add 5 onto it again. So now if we print var1, obviously, I mean, let's be honest, you probably know what we're going to get. It's 11. So we can also redefine variables as long as we use proper syntax. You cannot add a string in a number. So that about does it for the recap. I don't think there's really anything else we talked about or anything else you really need to know about for now. Just make sure you have like a basic idea of what a variable is floating around in your head. I don't want you to forget about it. Don't forget about it. But just have like a vague idea kind of floating around because we're going to start using it more and we're going to start applying what we know now. So now, unfortunately, we're going to have to learn a little bit of theory, if you want to call it that, in order to understand the syntax that I'm about to use in this tutorial. So, you remember how in the first episode I talked about these things called services? The services are just all the main big puzzle pieces that kind of make the game work. So, you probably know that let's just go out of the script here. When you insert a part into your game, you see it on your screen here, you might know that it goes into your workspace. And the workspace is just the service that renders, sorry, basically when you run your game, when you play your game and everything loads in, you see this. It's actually on your screen. All this other stuff, you don't necessarily see all this stuff, but all of these things have their purpose. You just don't interact with them as the player. But the workspace you do interact with because you do see the parts. And when I click on it, it highlights blue. You can see it. Spawn location, you can see it. The base page is locked, but if I click on it in the workspace, you can see it. So you can see that your parts are in the workspace. And remember that all of your main services here, including the workspace, are just a part of your game. And that's going to be a big word we're going to use when we define what parts are. Because let's say I want to load in and I want to change the color of this part. Well, I can do that by just going to its properties, and there you go. But what if I only want to do it at a specific time? Like, let's say I was at a stop light and I was driving. Well, obviously we can't just keep it the same color at all times, right? We can't just always have it green. Otherwise, well, yeah, I think you can kind of already guess what would happen, but you get the point. What if I want to change the color of a part? Well, today we're going to do that. And we're going to change a lot of properties of parts. Because parts have quite a few properties that we can pick from, and I'm going to go through a couple of them, but there's a couple, well, actually quite a few that do require a bit of scripting knowledge. So we're not going to mess with that for now. But we're going to go over the basic stuff. So, do you want to know how to change the brick color of this part? All right, let's go. So, let's go ahead and open up our script. Now, we're going to define a variable because you want to change the brick color of this part, right? But how do we define this part? Like, how do we find it? Take a guess. I'll give you a hint. It's in something. What is the part in this Explorer tab? What is it in? If you guess the workspace, you're correct, because if we close the workspace, we see that the part disappears. Remember how I said everything in your world is in the workspace? Everything you can see here, like your part, it's in the workspace. It has to be in your workspace for you to see it. So I can see it, so it's in my workspace. But how do we script that? Well, let's go ahead and do that. I'll show you. So remember how I said, let's close all of this really quickly. Remember how I said all of these services are in something called the game. So collectively, all of these things are the game, or they're a part of the game. The game itself, you could think of as holding all of these things in it. So you know how the part is in the workspace? Well, think of the game as holding all of these, but you can't actually see it. So this is where we're going to start defining some stuff, and I'm going to break it down as best as I can, but you're going to have to just slowly let yourself get used to this syntax, this language that I'm going to use here. So we're going to define a variable. We're going to call it local. So remember, when you define a variable, right? I'm not going to talk. Listen, when I explain things initially and I do a recap, I'm going to start expecting you to know some things. And so I'm going to start kind of just writing stuff down. So make sure you understand what I said in previous episodes. I've covered local, what you need to know about it for now. So write local, go to workspace. What do we want to call this variable? Well, what does it represent? Well, it's going to represent the part, right? Because that's what we want the variable to mean. We want to give it a meaning, and we want it to be the part. So let's call it part one, let's say. Because maybe I have a bunch of parts I'm going to put into this script, and I'm going to define all of those parts. So you can't just name all of them parts, because you can't have, like for instance, say local num1, right? And you name all these num1. So local num1 equals 2. We can say local num1 equals 5. If we print num1, what do you think is going to happen? Well, let's print num1. Well, you can see it chose one of them. That could be problematic. So basically, yeah, we define the variable up here, and then we defined it again. We didn't redefine it. We're literally creating the variable again. But because, I don't know if I've explained this, but scripts go top to bottom. So they go top to bottom. They start on the first line and they work their way down when it runs. That's how scripts work. They start from the top and the computer kind of just says, okay, I got this line. Okay, there's nothing here. Let's go to the next line. Okay, I got this line. I'm gonna run this. The reason you don't want variables, especially for parts, to be the same is because it only is going to take one of them. That's going to be a huge problem because maybe you have two parts and you want a variable for each one. Well, you can't just give it the same variable name. So remember to make your variable names unique. Okay, remember to do that. So part one, well, let's say part one equals. So here's where we're going to get into the syntax. Okay, so the first thing we always start with when we try to, if we try to find anything that you see these, what I'm highlighting blue, anything that can be highlighted blue in this Explorer tab, if you want to reference it in your script, if you want to reference anything in your Explorer, so any of these services, anything in the services, in the server script service, in the lighting, anything that's in the lighting, anything, the first thing you always use is what's called a global. A global is just a variable that Roblox defined for you. And they have unique features to them. So, you told me about global variables, you say. Well, why you tell me about this? Are you going to show me one? Yes, I'm going to tell you one global variable called game. Game, remember how I said everything here is called the game. So everything is in the game. Everything here makes the game. That's kind of the intuition I want you to have. So when I refer to anything in this Explorer, we start with game, which is a global. Remember that, which means we can use it anywhere in any script at any time. The next thing we're going to use is dot. So dot means I want to go a step down. So I'm up at the game. I want to be able to reference any of these things. So what do you think I want to reference to get to our part? Well, what's the part in? It's in the workspace, right? So the next thing we're going to reference is the workspace. We start with game, we go down. So when you go down from game, now you can choose from any of these things. So I'm going to choose workspace. So you just type out literally what it is, like what it's called. And you'll see it pop up right here, but I'm going to type it out here. So workspace. Now, what do you think happens when I do a dot again? Where are we now? Well, if you guessed we are inside of the workspace, you're right. So what can we choose from now? Well, you said you wanted to go in the workspace, so now you can choose whatever's in the workspace, which is what I've highlighted. So what do we want to choose? What are we looking for here? We're looking for the part, of course. So let's type that out. Part. Game.workspace.part. So we start at this game. So think invisible, this invisible game that holds everything here inside of it, right? Just think of it as like that for now. Then we put a dot. So now we're here. Okay, well we reference the game, but we want to go down from game. So let's start referencing everything that's highlighted here. Okay, well I want to go to workspace, so I do dot workspace. Okay, well, now we're in the workspace. So all right, here we are. We reference the workspace. Then we added another dot. Okay, well now we need to go down again, so we're going inside the workspace. So we put a dot, so we're going down. Or well, like further in. And now we have all of these selections. Okay, so what are we choosing? Well, let's choose part, because that's what we want to change. And there you go. So we have stored the location of this part right here. So when I go to my base plate, this part right here, we have defined in this name, this variable. So believe it or not, we can actually edit the properties of part, all of this stuff, everything in our script. So let's do that right now. So first thing, we're not redefining the variable because all we want to do with the variable is know what the part is. That's all we want to do with it. It's not like we need to change it to another part or something. No, we're just going to use that variable to reference the properties. So how do we reference the properties? Well, I'll give you a hint. It's all on the left. These are the names of the properties. And that's how we're going to change any individual properties. We start, of course, with the part itself. So we're going to do part 1. And remember, you replace whatever the part 1 name is equal to. So we basically just said game.workspace.part. Okay, so we have the part. Now we put a dot. So we're going to go in the part and I want to change the properties. The properties are a part of the part. That's why we put a dot. So think of it like that. We're not referencing base plates properties. We're not referencing workspaces properties. We're every part in your game, everything in your game, sorry, has its own properties. Everything has unique properties, and so we're going to refer to part one's property, which is just this part in the workspace. What property we want to change? Let's start at the top. Let's start with brick color. So the first thing we write when we want to change a property of a part is we type the name of the property. So let's do part1 dot brick color, and you see it'll display because it knows we're trying to change a property. I'm going to type it out. See how it's exactly the name, brick color. So now we're going to introduce a little bit unique syntax for changing the brick color of a part. Okay, so this is a unique case. Trust me, okay? I would say for now, just try to memorize what I'm gonna type because I can't actually fully explain to you currently how this syntax works, okay? I'm sorry, I can't. But I'm gonna try to give you kind of just a watered down but still pretty good idea of what it means. So we're gonna say it equals because we want the part1 dot brick color, we want it to equal something else. So if we open up this, we get this little, I don't know what to call it, collection of colors. I know there's a color here called really red. I'm gonna go ahead and undo, but that's the color I want. So it's called really red. And remember, brick color, if you want to change a brick color, you have to remember that these are all names. They're all strings. See how it's really red? That's a string, really. So, I mean, what have we defined a string as? Just words, letters. So if you want to redefine a brick color, you have to use a string. But the syntax isn't that easy. So now let's get to the tough part. Okay, so like I said, the syntax is a little strange. Why isn't this? Sorry. Let me. You know what? Let me just do this. Medium stone gray. Okay, there we go. Okay, so let's put it back to medium stone gray. So when we look at it, it's gray. Okay. So here's the syntax. If we want to change the brick color of a part, we're going to do the part dot brick color. So we're referencing its property, the brick color, and we do that by referencing its name. Then we say equals because we want to set it equal to some other color. So once again, I'll say it again, this is a unique case. A lot of these other properties are actually very straightforward, but this one you have to do it this way, okay? So we're gonna write brick color dot new, sorry, new, and you're gonna get these parentheses. Now, if you are, I don't know, a literal genius, you could probably tell that this is a function. If you know that, you're a genius, okay? If you figured that out, I am shocked that you knew that. Let me know if you knew that that was a function. I bet you none of you knew that. Maybe like 0.3% of you knew that that was a function. Because like once again, I haven't even talked about functions. But either way, let's get that out of your head. If you didn't figure that out, you don't need to. Okay, that's not the point. We're doing functions later. But dot new for now. Here's how I want you to think of it. So we want part1 dot brick color. We want to change the brick color. Let's put it to a new brick color. Then inside of these parentheses, we're going to put a string. Now, when you insert a string, you should get a list of every color in this the little chart here, which is a lot. And so if you click on it again, you might get it might disappear. So just do another pair of double quotations and it resets and you get it again. But I said I wanted really red. And remember, you have to type the color literally as it, what the? You have to type it literally how it's spelled in the properties tab. So, once again, local part1. So we named a variable and we want that variable to represent the location of the part. So we defined it. So game, which is a global, which means we can use this anywhere in any script at any time. And what the game represents is it's just an invisible thing that is above all of these and has all of these in it. Dot just means we want to go down the order. So Now, everything I have selected is available for us to deal with. I chose workspace. So, okay, well, we have the workspace selected. Then I add another dot. Okay, well, now we're listing everything here. So now we can choose from anything in here. Yet I want part. So you have to use it literally as it's named. Remember that. So keep in mind, let's say I duplicated this part. So you can do that by doing, yeah, duplicate it. Boom, two parts now. Remember, the script isn't going to be able to just tell what part you're talking about. So remember, you got to name these parts properly here. Um, so maybe you could do like part two, maybe something like that, right? So if you have two parts that have the same name, it's also not gonna know what part to choose, what one you want to change the color of. So keep that in mind. So either way, we're done. It's done. You can go ahead and run your game. And of course, let's see what happens. We want to change our brick color. Oh yeah, sorry. So part one dot brick color. So we're going in part one. So dot. Okay, well let's go in the part so we see its properties. And I want to choose brick color. So we choose it from its property name. Then we set that property name equal to, and then we change the value of that property, which is brick color. And the value is just going to be a new brick color. And we just use this fancy syntax called brickcolor.new. And then we have open parentheses, stuff like that. And then we put a double quotations because the value of the brick color is going to be a string always. So any of these colors you choose is just text. It's a string. And inside that is the list of all the names for all of these colors and the colors that those names represent. So I chose really red. So that's about enough explaining syntax. Let's go ahead and run the game. And wouldn't you believe it, you just changed the first thing in your game with scripts. Shocking. There's so much more you can do with scripts. Trust me. You're gonna love it. So, this is pretty much the end of the video. This is pretty much everything I wanted to talk about. Just get you familiar with, how referencing or like locating something works, like how to locate something in the workspace specifically. Okay, I don't want you worrying about any of this other stuff. We're only focusing on the workspace for now because it kind of is the easiest to discuss. And all of these services have their own uses, but those are for later episodes. So we figured out that game is a global, which means you can use it anywhere just to, like, let's say you want to reference something in this Explorer tab. You're looking for something in this Explorer tab, let's say a part, okay? Just let's say hypothetically, well, you could say game dot. So we're going, okay, well, now we're going down. Now we can choose any of these. Workspace, okay, we're going to workspace. Okay, we did a dot again, so now we can select anything in the workspace. And we chose part. So part one is part. It's this part. That's what it is. So part one dot brick color equals a new brick color. And we're going to set that new brick color to really red. That's what we did. It's that simple. And all you got to do is remember this little fancy syntax. Everything else should make sense to you intuitively. Like part one dot brick color, because part one has properties, and each property, to reference them, you just pick its name, right? Part one dot brick color. We just pick the name. And we set that equal to, and then this is where the fancy syntax comes in, brick color dot new, open parentheses, close parentheses. You put a string, and then in the string, we write exactly word for word the color we want to set the part one to, which is just part. Oh yeah, and then I said, I don't know if I said I was gonna do one other thing just for fun. Um, oh, sorry. I forgot to change other properties. Okay, so next one we're gonna do is, let's say anchored. So if you don't know what anchored is, I'm gonna make it fairly simple. Okay, so basically in Roblox Studio, have a part and just put it in the air. Now, I want you to make sure that this anchored is unchecked. So it's checked, uncheck it, and then run the game. See what happens. it falls. And obviously our script is working. We set the brick color, but don't worry about that. So it fell. So gravity basically applies. Now let's anchor it. We run. Oh, it's stuck in the air. It's stuck. Gravity's not affecting it. So that's what anchor does basically. It anchors it in position, in the position that it's in. That's essentially what it does. So we're going to leave this checked. Okay, so now we're going to learn another data type. And this data type is called a Boolean. So a Boolean has two types of data, true and false. So let's go back to this part here. And we want anchored to be off. How do we do that? Well, obviously, if you picked up anything that I said earlier, the first thing that you write is part1 dot, and then you put the property name. And what's the property name? That's right, anchored. Hold up. Oh, okay, hold on. Let me just erase that. Anchored. And, oh, you already saw that. Hold on. Anchored. Boolean. So it's telling us that if we want to change whether this part is anchored or not, we have to use a Boolean. We have to set it to a Boolean, which just means is it true or is it false? So basically, is part one anchored or is it not? So let's set it equal to. So we want to set the value of anchored. This is the value right here on the right side. That's what I mean when I say value. It's going to be equal to off. We want it to be unchecked. So remember this. True means on. False means off. So if we want it to be off, we have to set it to false. So let's say equals, and then we just type false. That's what we do. So let's go ahead and run. But since it's on, it will stay in the air. But since we changed the property of anchored in our script to false, it should fall when we run the game, right? Even though it is anchored here. Because when we run the game, the script will run. So let's see if it works. And there we go. If we click on it, we can see that it is not anchored, even though it was before we ran the game. If we go back, we see, oh, now it's anchored again because we changed it in the script and it ran and it changed it to false. So now let's set the parts anchored to false. So now it's going to fall when we run the game. But let's say I want to set it to true in the script. That means it's going to be checked when we run the game, which means it's not going to fall now because we set the anchored property to be true. And there we go. Now it's not falling, even though it's disabled by default. When we click on it, we can see that it's actually anchored, even though when we stop the game and go back down, it's not anchored, which means it should fall. So that's how a Boolean works. So anything with a check mark here, sorry, for part, you can change that property by using a Boolean. So you do the property name, and you set it equal to one of the two Booleans, which are true and false. So right now, cast shadow is true, and anchored is false. So just keep that in mind. You can play around with that for a bit. And then obviously the next one, which is pretty straightforward. I mean, what's the last data type we haven't talked about? Numbers. So you can see transparency is a number. We can just change it from 0 to 1. So first thing we do, we go part1 dot, okay, what's the property name? It's transparency. So let's auto type that in. Equals, so we want to change the value. And what's the value right now? Well, it's 0. Well, when the transparency is 0, this object is fully visible. When we set it to 1, the object is fully invisible, so we can't see it. And anything in between is kind of visible, kind of invisible. It's in between, invisible and not visible. Or sorry, I just said the same thing. Invisible and visible. So right now it's 0. I want to change it to 1 when I start the game so you can't see it. So let's go to our script. Equal to, and we use a number data type. So what do you think we're going to use? What syntax are we going to use when we change transparency? We're just going to use a number. It's pretty straightforward. So right now it's 0. We know that the max value that it can be is 1. So let's set it to 1. We just type 1. So when we run the game, oh, it's gone. It disappeared. Because the transparency is 1. We just changed the property. So that's pretty cool. Now, for now, honestly, I think those are all the properties that I'm pretty much going to talk about. I mean, all this other stuff, there are some things here that I'm going to talk about in later episodes, like C-frame, pivot, material, because with materials, I'm going to introduce something called enum, which is another data type. Um, but enum, I'm going to do that later. That's definitely, I don't want to fry your brains too much, so for now, just understand that with variables, you can, well, actually, you don't need the variable actually. So let's get rid of this variable. So really, well, first of all, let me go back here. So what did this part 1 actually do for us? Remember, when we use part 1, we're just replacing the name with whatever is equal to. So really, wouldn't that be the same thing as this? Wouldn't it be the same thing as that? Game.workspace.part.transparency equals 1. Let's run it. See that it's 0 right now. It does the same thing. The variable just lets us, it's basically just a more efficient way of doing all this stuff. Because if I wanted to change, let's say the brick colors, I'd do game.workspace.part.brick color equals brick color dot new, and then I do, I don't know, really blue. And then we play, and then wow, it works. Oh, but you can't see it, but you can see right here, you can see the property is really blue. I forgot that the transparency was 1. Anyhow, this just kind of seems really long. And then I'd have to, let's say I want to change the transparent, or let's say I want to change um, anchored, right? So we'd say, oh god, we had to type it again. Well, that part, sorry, parent part dot anchored equals false or whatever, right? It just gets annoying. So you notice how all this stuff right here, this first half here, like this game.workspace.part, we could literally just save ourselves some time by just doing local part 1 equals game.workspace.part. And instead of writing game.workspace.part every time, we can just bring this back and instead just use part 1. Part 1, or sorry, hold up, let me get rid of this. Oh, what did I do? Uh-oh. Okay, there we go. I think I fixed it. Part 1, and then let's just erase this one. Part 1. And it does the exact same thing. We just set it to be a variable, so we don't have to keep saying game.workspace.part every single time we're trying to change property. So that's basically what I want to talk about for this episode. I hope you guys learned. Sorry, my computer just died. I don't know. But I think I think I was saying, yeah. So I hope you guys enjoyed, and I hope you learned something from this. I hope this helped you out. And once again, I do recaps every episode, so if you don't fully understand it now, I'm gonna recap it anyway. Just watch that. If you're a genius, you're a little wizard. You can go ahead and skip the recaps. That's fine too. But it doesn't hurt to watch the recap. The recap is just a shorter, kind of condensed version of the full videos. And it really helps out to just like refresh your memory because you might have already forgotten like how do you change the brick color dot new and then string, like you know sometimes you can forget to do that. You have to really pound it into your head. So go ahead and practice. And I've been thinking of adding like quizzes to every 5 episodes. I was thinking of writing like a test or something that I would get you guys to do, and I would leave it at the top of the comment section, and I'd just see your guys' replies. And maybe if you notice that somebody else has a wrong answer, you could reply to them and say like, "Hey, this isn't actually true. It's this." And even I will chip in, like I'll, give you guys some feedback. That'd be really cool. I'm thinking of doing that every like 5 episodes. And it's gonna fully recap like everything from the previous 5 episodes. So it's gonna recap 5 episodes at a time. So I'm gonna ask questions based on 5 episodes. Okay, that's what I'm planning on doing. I think it's an interesting idea, and I hope that maybe that could help some of you guys out and test your knowledge to make sure that you're keeping it in your head. Because you can forget about this stuff so fast because you just learned it, right? So you gotta make sure you start applying this stuff and keep doing repetitions. Go write out a couple print statements. Go make a couple variables. Um, Locate some parts. Try to figure that out in the workspace. Rename it and then find it. Stuff like that. Just do some exercises. So I'm thinking I'm gonna do that. But either way, I think that wraps up this episode. Of course, if you guys want more content like this, more tutorials coming your way anyway. But if you want to like and subscribe, I'd really appreciate that. You don't need to do any of that, of course, but maybe if you do want to keep updated on the series, see when I post a new tutorial or something, you can always have it there in your notifications. So, but either way, that's about it for this one. So, as always, until the next one, I'll see you guys later. Peace. Hey everyone, welcome back. Aversile here with the fourth video in the scripting series. Today's episode, I decided we're going to talk about functions. In previous episodes, you might have heard me mention functions a couple times, but today we're going to formally talk about functions. And I'm going to try to explain everything I can when it comes to functions. So it might be a lengthy video, I predict. So get ready. Um, if you have to come back another day and, watch this video, because functions are extremely important. But functions can get pretty complicated because functions allow you to organize your code in different ways. But I'm not gonna keep babbling. I'm gonna show you what functions are. But first, of course, you already know I gotta start with the recap. So last episode, we talked about properties and that we can actually change the properties of parts. And we can do this by understanding the relationship between all of the services here and a global variable known as game. And game is what we use when we want to access any of the services in this Explorer tab. And of course, anything within those services, including part, which is right here. So we talked about a special keyword called game, and we use game to be able to change the properties of, say, these parts. A part that I might insert into the workspace at some particular time. So I can go right click, insert object, go to script, and then we can either define a variable for this part in the workspace, or we can just type it all out in one line. So I could do game dot workspace dot part, sorry. And let's say I want to change the transparency of this part. So you name the property name, and then you set it equals, and then you set it to the value you want to set it equal to. So maybe I want to do 0.5. And that should make it see-through, but not completely invisible. So if we click run, we'll see, here it is. Look. So if I click on the part, you can see its properties in real time. And you see that it's 0.5. So that's pretty cool. And then when you stop the game, now it's 0 again. So you can change properties by using this special game variable. It's called a Roblox global. Basically, this was made by Roblox, And they've allowed us some special features with this, not just that we can access the services in the Explorer tab, but some other interesting things that we will talk about at a later time. So game is very special, but just understand that you have to use it if you want to reference anything else in this Explorer tab, like the workspace, for instance. So in essence, that's basically what we talked about. And then of course I said, well, we can also do a variable. So let's say I did local my part equals game dot workspace dot part, and then we can just use that variable to change any property we want. So I could say part my part dot brick color equals brick color dot new using this special syntax, and then we can change it to, let's say, I don't know, cadet blue, let's say. And then we just run the game and we'll see that the color changed and now it's cadet blue. And then of course when we stop the game it goes back to medium stone gray. Oh, and then of course I talked about booleans. So if you have any property with a check mark here, the way that you change it is, well, there's two states, true and false, on and off. So this is off, this is on. On is true, so checked equals true. Unchecked equals false. So let's say I want to change the anchored property, which means that it is influenced by physics, or let's just say gravity for now. So you know that objects fall. So when anchored is disabled, if we run the game, forces apply, and it falls. But we can actually change that in our script. So we could say my part dot anchored, and we can see that it's a boolean. So it says whatever it's equal to is either going to be true or false. Well, right now it's false because it falls. So if we set it to true in our script and we run, it's not going to fall. You can see here. There we go. Let's go. So then we talked about booleans. We talked about, so let's say you want to change the transparency. I talked about use the number data type because these are defined using numbers. Just stuff like that. We went over some basic properties. And I said there was going to be some that I'm going to talk about at a later time because they do require quite a bit of scripting knowledge. So that's pretty much the properties we're going to talk about for now. But I just want to introduce you to this idea that we can actually specify parts or things in our game, and we can change various properties and do various things with those things. So I just want to introduce you to that idea, get that flowing in your head. And that about covers up last video. So now we're going to talk about functions. So get ready, it's going to be a little bit of a long one. I got a lot to talk about. So the main topics we're going to be talking about are functions. We're going to talk about scope. We're going to talk about arguments. Those are the four main concepts we're going to discuss today, and each one is going to take a considerable amount of time. So this might take you a while to sit through, but trust me, once you get this done, you're going to understand everything that you need to know for now about functions, and functions are going to make a lot more sense to you if you just bear with it, okay? I know my videos can be pretty long sometimes, but I want to make sure that you guys get every piece of detail that you can. I don't want you guys to be confused. I know how that feels sometimes, to be just left in the dark because you don't really understand certain things. You know, there's gaps in your knowledge. I don't want to do that to you guys. So let's go ahead and delete this part. Control X if you don't know how to do that. So I'm going to go ahead and just delete whatever's in the script here. And the first thing I'm going to do is I'm going to discuss the syntax for a function. So the first thing that you write down is local. Then you specify that you're talking about the function data type. So to specify that it's a function, we have to write the word function. Then we name the function. So I can call it my function or something like that. I could say print something. So let's say I want to print something in this function. Then we're going to do open closing parentheses. Then we're going to go over and we're going to click enter. So it should look like this, and you'll see that it automatically indents inside the function, and you'll also see this little end thing. This means this is where the function ends. So anything outside of that, or anything below that end, or anything above this line, defining the function is not going to be the function itself. It's going to be outside of the function. But anything within these two things here, so end and local function print something, is the function. So what is a function? Well, I already said that a function is a data type, and the purpose of a function is to run a specified amount of code when you call the function. So what is calling? Well, it's basically like getting it to run. That's essentially what calling is. It's just getting the function to run. So basically this function will not run unless I call it. And to call it, you simply write the name of the function. I'm going to type this out, so print something. You'll see it pop up immediately. And then we're missing the open closing parentheses. That means, okay, this is a function. This isn't just a variable. Because if we erase that, we're going to assume this is a variable. It's not a variable, it's a function. And this is the special syntax you have to use to define a function. So when we write out the name like this, the name of the function, this is going to run whatever is in here. What? Nothing's in here. So nothing is going to run. So we need this function to do something. So let's define what we want the function to do. Well, I named it print something. So let's print something. Let's do print, and then let's say, hello, I'm Bob. Return of Bob. So we run, and look what happens. Hello, I'm Bob. But if we stop here, if we go back to the script and we get rid of this call, so without calling the name of the function, basically that makes it execute or it makes it run. If we erase that and then we run, you'll see that nothing actually prints because we didn't call the function. So that's why functions can be pretty useful. They help organize your code and make things only run when you really need them to run. Because maybe you don't always want this to be running. Maybe you only want it to run at certain times. And we'll get into applications when you're ready. But I just want to introduce the concept of a function. It's just a block of code that only runs when you call it. And to call it, you basically just use its name and then open closing parentheses to define that it's a function. That's basically what it is. That's all it is. So now I want to talk about something which can be a little confusing at first. Even for me, this was one of the things that when I started coding, I struggled to understand. But I want to talk about something called a parameter. A parameter is basically a placeholder that you can use in your function that can be resubstituted when you call it. So let me give you an example. So let's call this function add numbers. And let's say I have two numbers, x and y. Let's define a variable called sum equals x plus y. Then I'm going to return sum. Okay, well, let's go ahead and add numbers 2, 3. But then let's print it out. Let's print it out. Once again, I do not expect you to understand any of this right now. That is not the point. So 2, 3. Let's see what result we get. We got 5. How do you get 5 by adding 2 and 3? Well, you add 2 and 3. Where does that show up in this function? X plus y. So now I need to explain. All right, you notice how you have two parameters. So this is a parameter. This is what's called a parameter. An argument, so now that you have a better idea of how a function works, I want to redefine what an argument and a parameter is. So a parameter is basically a placeholder variable of sorts that you use in your function and you return it to be manually inputted by you. So this return word used to confuse me a lot, but I'm going to try to clear that up as best as I can for you guys, okay? I'm going to give you guys like a kind of an idea of how to look at it. So x and y are two parameters and we use it in this sum variable. An argument is basically the values that you set your parameters to equal when you call the function. So that's why when you print, like let's say you print 2 and hello Bob. Those are your arguments because the parameters, well, they're already preset by Roblox because it's a function that was created by Roblox. You didn't make the function, Roblox did. So all you have to do is insert the arguments or just the values that you want the parameters to equal. But Roblox takes care of that. But if it comes to actual regular functions, we have to define everything, including the parameters. So the parameters are the placeholders for your arguments. That's what they are. X and Y are basically placeholders that we're going to use in our function, and then when we call the function, X and Y are going to turn into whatever arguments you pass through when you call it. And what's going to happen to your parameters depends on what you define them as in your function. So what we did here is we added x and y together, and then we returned the sum. So first of all, ignore return. We know that the thing that we want to do with x and y is to add them together. So remember when I put 2 and 3 as my argument, I got 5. So it worked. 2 plus 3 is 5. But why can't we just erase return? Why can't we just do that? That makes way more sense. Define a variable and set it equal to x plus y. And also, you might be wondering, why do we print add numbers 2, 3? Well, the reason is because if we just call the function as it is, like let me do return again. So return sum. Let's just do add numbers 2, 3. Let's run. Do we get 5 in the output? No. Why? Because the function isn't just going to put it in the output. You have to remember how I said you have to print to put something in the output. Calling a function does not mean it's just going to go in the output. You still have to print whatever add numbers is going to give you. So as I was saying, let's get rid of return sum. Let's go ahead and run. Let's see if it works. It didn't work. Why didn't it work? Well, let me explain. Now you might be wondering, why can't I just do this? Why can't I just define the variable sum equals x plus y? Because you're not doing anything with the variable, you're just defining the variable. Remember, add numbers 2, 3, there's no connection with sum to any of these. So how do you make that connection? Well, you say return sum. And what that does is it sets the value of the function equal to whatever you put next to return. And remember, this is just a variable. So really, we don't even need to write this variable. We can just say return x plus y. Remember? Remember the rules I said about variables. Whatever the name is, it's equal to whatever's on the right. So we could literally just say return x plus y, and it'd do the same thing. So we have our parameters. We want to use those parameters, and we want the function to be equal to whatever we do with those parameters, which is x and y. So let's say I want to set the function equal to, I want the function to return x plus y to me when I call it. Okay, so I called the function, and I use the arguments 2 and 3. So the game goes, okay, so he has 2 arguments, 2 and 3. Let's go to the function. Okay, so we have 2 parameters here, so he just replaced x and y with 2 and 3. But what do you want me to do with it? Okay, so it wants me to give him this here. Okay, so here's what they want me to do with the function. They want me to return whatever x plus y is. So I want you to imagine it like this. Okay, computer reads, okay, here's a function here. All right, let's go over it. Okay, I got the function. Okay, it wants me to call this function here. Okay, let's go back to this function. Okay, we have x and y as parameters. We can see that they replaced it with that. Oh, okay, let's see. So what do they want me to do with the function? They want me to return x plus y. So what's x plus y? Well, we have 2 parameters here, and they said they wanted 2 and 3 to be replaced here. If they want me to return x plus y, and x and y are 2 and 3, then this is what I'm going to print out, x plus y. So when you print it out, you're going to get x plus y, whatever x plus y is, and whatever you put for the arguments, which is 5. 2, 3, return x plus y. So x would be 2, right? So you define x here. Y would be 3. And the function only knows what to do with this call only if you use this special word return and then whatever you want done with these two parameters. So I know that can be confusing because the syntax can be a little overwhelming when it comes to functions. So I want to do another function with you guys because I know this can be really tough to really get this return. I don't know if I explained it well enough, but we're going to define another function. We're going to call it local function multiply numbers. We're going to call it, so you can probably assume what I want to do. And this time let's do A and B. So when I call this function, what do I want? Well, I want whatever A times B is equal to and whatever I set the arguments to equal. Like for instance, I'll show you. So let's just call the function, and I want to be able to substitute A and B, and it's going to multiply those together. So let's say I want to multiply 5 and 4 together. Well, 5 times 4 is 20, but how do I do that? Well, when we call the function, I want the function to return whatever A times B is equal to, or A times B. You can write it this way too. A times B. So when I call the function, I've replaced A and B with my arguments, and when I call it, I want to return whatever A times B is equal to. So if we run, we should get 20. Let's run it, and we did not print. Yeah, sometimes see, like sometimes even I can make mistakes, guys. So you gotta print it. The reason you have to print it is because just calling the function does not put it in the output. It's not just gonna put it in the output just because you called the function. The script is still running the function, but you just can't see it because the only way to see stuff happening is because you have to print. That's why I told you print is super important if you want to see what's going on in your scripts. So this worked, it's just that I didn't print. So if we run, it's actually going to give us 20. There we go. So if I set, let's say, if I set this equal to 6 and, or let's say 7 and 7. Well, if you know your times tables, you'll know that it's 49. So we're going to get 49 is 7 times 7. So we define our function. We give the function a name. We define its parameters, which means the placeholders that we want to do something with inside of the function. We end the function, and then later on we call the function and replace its parameters with our arguments. And the only reason that the function knows what to do with our arguments is because we returned whatever we want these placeholders to do, which in this case is to multiply them together. So think of return as saying, okay, function, I want you to do this, right? And whatever goes beside return, this is what I want you to do. That's going to be your goal. So when I call it, it's going to do this, right? That's what it's going to do with these two parameters, these two placeholders. So I know return can be a weird word. It can be weird to understand, but the best way I can think about it is that we should start at the bottom and work our way up. So we called the function. So the function says, okay, we were called. Okay, so what do you want to do? Okay, well, let's give you A times B. That's what I'm going to do. I'm going to give you A times B, which is our parameters, and our arguments just replace the parameters. But the function itself, what the function does, is whatever we're returning in this case. So I hope that makes sense. I'm going to try my best to recap next episode because I know return didn't stick with me. It took me a bit to fully just remember and understand exactly what's going on. But it's just special syntax that means I want the function to do this specific thing when I call it and give arguments. Like for instance, let me make it less complicated. Let's say local function print something. Let's go back to this. And let's say I want to print my name is Bob. All right. I'm probably never gonna stop using Bob as an example, but so then we can just say print something, right? That's what we do. That's what we did last time. We print, and there we go. My name is Bob. But another way we can do that, instead of putting the print in the function, we can actually return my name is Bob. So what do you think that does? So we haven't called the function, but let's print the function. So print something, print something. Let's print it. Let's see what happens. My name is Bob. It printed. So basically, the function was equal to whatever this string was. Because remember, like variables, for instance. Let's say local text equals hello, and I print hello or text, right? It's the same concept. Hello is basically text. And then likewise, when we printed and we got my name is Bob, that's because print something as a function was equal to this. So I hope that makes a little sense. So you can see in this case, we could literally just substitute print something with my name is Bob because that's what we got, that's what printed out. So when we called print something, the function said, okay, let's see here. So it's telling us to give us whatever this is back when we call it. And so likewise, when I do local function add numbers, and let's do A and B, and we do return A plus B, and then we print add numbers, and then we pass our arguments, so let's say 5 and 5. So that's going to do 5 plus 5. This is basically saying when I call the function, what I want to happen is basically whatever thing we're returning. Now, I don't quite want to say the function is essentially equal to whatever we're returning. That's not really a good way to put it, but if you have no other way of understanding it, that's fine if you want to think of it that way for now. It's not really bad if you think of it that way. Like, I'm just going to set the function equal to that. But I think you're kind of missing the point a little bit. So I called the function. Okay, let's look at what the function is. Okay, so it says we want to return a plus b. So whatever we put in our arguments, we're going to return whatever this thing is, whatever we put here. And so it says, okay, let's give them a plus b. So we spit it out. We get 5. We insert 5 and 5 into whatever we're returning, and then we get our value, which is 10. So we run this, and we get 10. Boom. So that's kind of the best explanation I can give you of return. Once again, the intuition comes with repetition for this kind of thing. It's just awkward syntax. It makes sense when you understand how your script flows of sorts. So if you don't fully understand this, that's completely fine. You don't have to. This stuff takes time. I didn't instantly understand this. I actually struggled to understand return and actually shied away from it. But return is super important, guys. Okay, so do some math problems, practice using return. And once again, we can also define it in a variable. So we could say local sum equals a plus b, and then we could do return sum, right? It's the same thing. So we call the function, we have our arguments. All right, so they called it. Okay, let's see what we want the function to do. So we want to define this variable. Okay, so we're saying a plus b, and we want the call to return to us whatever we put here. So when we call it, we want to return whatever this is to this print thing. And what we get is the sum. So we're going to print whatever the sum is, basically. Now, there are a lot of different uses for return, but what I all basically want you to understand about return is that it basically spits out whatever you put as the return when you call the function. So remember that text we did? So let's say I wanted to return Bob, and then I print this, and there's no parameters now because we're just printing a string. And forget that it's called add numbers, and then we print, and it's just going to return Bob, which means for add numbers, when we call that function, it's just going to return Bob to us. That's all it's going to do. It's going to give us that. And when we run, we get Bob, right? So that's pretty much all I'm going to talk about for Bob. Now we're going to turn direction a little bit. We're going to talk about scope. So this is where you're going to understand why we use local and why local is best practice, unless you know what you're doing. So let's say I had a function, local function, my function, and whatever's in here. So let's say local number equals 5. And you remember how you can redefine variables? Let's go ahead and try to do that. So number equals number plus 5. Now, the problem with this is not the same thing as local number equals 5. This is not the same thing as that. Why not? Because this variable is restricted to this function. That's what local means, right? So let's try printing number. Let's try printing number. Okay, sorry, I messed up. First you have to call the function for this to exist. Okay, remember that. All this code does nothing unless you call the function first. So call the function and this variable will exist. But let's do local, number equals 5, okay? My function, so we call the function, so now local number equals 5 should exist, right? Well, let's print number. We'll see if it works. We get nil. Okay, well now let's get rid of local. Let's get rid of that. What happens? We get 5. So what's going on here? Why are we getting 5? Well, that's correct. Number is equal to 5, but why doesn't it work when we use local? Well, number is now what's called a global variable. So there are two types of variables I want to talk about, a global variable and a local variable. A local variable is restricted to whatever block that you're in. So this block is called a function, and it's a block. So if you have this arrow thing here, whatever's in here is the block of code. So this block of code is restricted to the thing that it's in, which in this case is a function. So number equals 5. See, look, it says global number is never read before being written. It's basically saying you should probably put local because you don't want to mix up other variables. Let's break it down. We define a function called my function. We define a variable. Let's go back to local here. So we defined a variable called local. We called it number and it equaled 5. We then called the function and now we want to print number. We want to print whatever this is. But we can't. It equals nil when we tried. And that's because it's local, which means it's restricted to the block of code that it's in. If we take away local, now as long as we call the function, this variable will be accessible anywhere in your script, as long as it's below the function, because otherwise the function wouldn't exist. So like if I did print number up here, well, remember how it goes top to bottom? It goes up to down, up, down. So print number, this function wouldn't even exist as you printed that. So remember, it has to be below it. Remember that, okay? So as long as we call this function, number is going to exist, and that means it's a global variable, and we can call it anywhere. And the reason we don't do that is because it's bad practice, because you could confuse other variables that you write outside of the function with the one that is in the function. That's why we usually write local before we define a variable. So local basically restricts a variable to the block of code that it's in. That's what it does. And I can show you something cool. So let's say we have local number equals 5, and we could just, you know, return number, and then we could just do return, and then we could print my function. And it's going to return 5, right? There we go, 5. Now, I think I want to clear up some confusion here. So basically, when we do this, we can't just access this variable unless it was global, right? So the only way to access what's done with variables in a function, generally speaking, is to return. So I will return number, which means when we call the function, we're going to return whatever we put beside the return. And so when we call the function, it's going to say, okay, well, we define a variable, and we want this call to be set to whatever we return, which is number. So when we print my function, it's essentially my function is the same thing as number. That doesn't mean that the function itself is equal to number when we return number. It means that when we call the function, the call is going to give you whatever you return. So if we have, let's say, two parameters, a and b, which are just substitutions, and we can call them right here. So this is a and b again, except now we're not doing substitutes, we're doing actual numbers. So let's say 5 and 10, and let's just return. Well, when we call this function, we want to replace a and b with 5 and 10, but whatever we return is actually what happens to a and b when we call the function. So we know what a and b are, but we don't know what we're going to do with a and b when we call the function. So what we return is whatever is what's going to happen when we call the function. So these arguments are basically the info that the function is going to use to execute whatever's in this function. So we're going to return, well, what do we want to happen to 5 and 10? Well, let's divide them. So what is 5 over 10? 5 over 10 is 1/2, which is 0.5. So it should return 0.5. There it is, 0.5. So why do we do local function? Well, this might get a little complicated, but let's go ahead and just define a local function, and let's call it stuff1. Then let's put another function, but we're not going to do local this time. Function stuff2. Then we're going to print, hello, my name is Bob. Okay, yeah. So let's try calling stuff1. Well, what will happen when we execute this function? Well, we have a function inside of the function, but this function isn't going to run unless you run it. The function that's in here, remember how you have to call a function for it to run? Well, nowhere are we calling stuff2. We're calling stuff1. So let's set this equal to local. Local function stuff2, blah, 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 blah. So remember how that global variable that we defined, we just first had to define the first function, then we had access to that global variable that we defined. But this is local, so let's try executing stuff2, and let's see what happens. Oh, attempt to call a nil value, which means whatever we said here is nothing. It's equal to nothing. It's not defined. But let's go ahead and get rid of local and see what happens. Let's print. Let's run, sorry. Wouldn't you know it? It prints, hello, my name is Bob, which means the function ran. It's because it's called a global function. So I don't think I talked about this, but what did I mean by local versus global variable? A global variable is a variable that can be defined, and then you can use it from anywhere in your script. A local variable is a variable that can only be used in the block of code that it's in. That's why when we did local function, it can only be used in this block of code that it's in, which is this function stuff1. And see how it's highlighted red again? It's unknown. But if we delete local, all of a sudden, it's defined because it's global. So you might ask, okay, well, how do we use this function while having it local? Well, if it's local, if you're smart, you might think, well, how the heck are we supposed to print if we don't set it to a global? It's simple. Remember how I talked about returning? If you return stuff2 and then you call stuff1, when you call stuff1, you're going to return stuff2. So basically, it's going to call stuff2 when you call stuff1. Because remember, whatever you return is whatever stuff1 is going to give you when you call stuff1. And in this case, we returned stuff2. So when we call stuff1, whatever we're returning is what we're going to get when we call stuff1 anyways. So what do you think is going to happen when we run? Well, let's see. Boom. Hello, my name is Bob. So we didn't have to use a global function. We just had to return. That's why returning is so useful. And I recommend you use this because then you can use your local variables and your local functions and whatever and just use return instead of having to find a bunch of global variables and risk confusing yourself. It just makes things so complicated. And I know the syntax is a little overwhelming because the past 3 episodes have been relatively easy, but this is just definitely a lot different. And so I am definitely going to be doing an in-depth review or recap, sorry, in the next episode, okay? Because I know this stuff can be a little confusing. And in fact, because I know this episode has been quite a bit harder, I'm gonna give you guys a little bit of a quiz in the comments. Okay, so go look in the comments and reply to my comment and give me all your answers. And just put the number for the question that you're answering at a time. I want to make sure you guys understand this, okay? This was one of the hardest things for me when I was learning to code. This is definitely one of the filtering episodes of sorts because a lot of people might stop for a bit when they see this because they're like, okay, this is too much. And I understand your frustration. Functions are hard when you're first learning them. They really are. So what have we talked about? We talked about functions, returning, and scope. So when I talk about functions, I'm just talking about any function. When I talk about returning, I'm talking about this word return. When I talk about scope, I'm talking about the difference between local variables and global variables, or global functions, or whatever, local functions. Just local, right? When you see local or no local, if you see no local, it's a global, which means you can use this anywhere. You can call this anywhere as long as you first call the function. If you don't call the function, it doesn't matter. None of this code inside here will work because you have to call it for any of this stuff to exist in any way. We talked about functions, we talked about scope, and we talked about returning. I'm going to give you a quiz in the comments and I want you guys to reply and I want to see that you guys are understanding this, okay? You don't have to fully understand everything, be like, the wizard who has all the answers. I just want you to start thinking about it more, and of course I will help any of you out if you let me know, okay? If you need help understanding something. So that about wraps it up for this video. Quite a lengthy one as I predicted. Pretty tough episode. I know it. I know functions are tough at first. Take your time, do the quiz, mess around with functions a little bit. I'm gonna do a recap in the next episode. But until then, that about wraps it up for this one. So I will see you guys in the next one. Peace. What's good, people? Adversile here with the 5th episode of the scripting series. Welcome back, y'all. How's your day been? I hope it's been good. I've decided that for this recap, I'm just gonna do the quiz from the last video. Because I feel if I did the quiz and the recap, that would just take too much time, right? So, and then of course today I'm gonna talk about if statements, or sorry, I'll just call it conditional statements, and that's pretty much what we're going to talk about. Sorry, that's pretty much what we're going to talk about for today. So it might be a little bit shorter of an episode, but yeah, we're just gonna dive straight into the quiz. So I'm gonna open up a script and you can go back to that video and just read along. So the first question is, so I'm going to create a comment. So a comment is when you put two hyphens or two dashes, and then it creates a comment line. So ordinarily, if I did blah, 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 it'd throw an error because this is assuming that this is actually part of the script. And in this case, it'd be improper syntax. But if I put two hyphens, it creates a comment, which means you can type text without putting it in a string or whatever. And I can just say, hello, this is a comment. And comments are just useful for commenting on your code. So leaving notes for yourself, like maybe something you coded yesterday and you want to come back to it today. It's just good for organizing your code and making sure that you can break down every piece of code that you wrote. I don't recommend writing comments too much though, just for places that you need them. And of course, the way that you write multi-line comments is two double square brackets and then click enter twice. And it should look like this, and then you can write multiple lines if you require that. Either way, question one was, what is a function? Well, a function is a data type that allows you to only run a specific block of code if you first call the name of the function. So let's just do an example. So local function. So we define that it's a function. It's a local function, which means its scope is restricted to the block that it's in. But in this case, it doesn't matter because it's not in a block. But it's always good. It's always best practice to include local when defining variables, functions. Then we name the function. And this generally has to do with what we want to do with the function. So let's say print stuff. Now, there's something unique about functions which allows us to store temporary variables called parameters. And let's say these parameters are, let's say it's message, sorry. And we're going to print message. And you can probably already figure it out. When we call the function, this parameter, we're going to refill with our argument. And that's going to print whatever this parameter is, and then it's going to replace that message, or that parameter with our argument when it goes through the function. So when we call it print stuff, and we include the message, right, because we're printing whatever the message is. Basically, the parameter is the temporary variable that only applies to the function. You can only use this parameter inside the function. And then we replace it with our argument, which is what we want the parameter to equal, the value of the parameter. And since we're printing something, let's just say a string, for instance, and we'll say, hey, Bob, sorry about that. So when we print stuff and we call it, we're replacing message with this argument, which means when we run the function, message is going to equal whatever our argument is, which means when we run the function, message is just going to be hey Bob, which is our argument. And you can go ahead and run this, it'll just print hey Bob. But either way, that's question one, and I believe question two and three as well, because I think it asked about arguments and parameters. So now we're talking about returning. So returning is something that's useful specifically for math. So if you want to do some math or you want to make it so that your function returns a specific thing when you call it, return is useful. And I'll give you one example with math. So we'll do local function add nums, and then we can return, well, we want to actually set the values when we call it, so let's define some parameters, a and b. And we'll do three. We'll do a, b, c. And remember, you can pass as many parameters as you want. Or sorry, you can set as many parameters as you want. So let's return, sorry, I had to burp, a plus b plus c. So when we call the function and we replace the parameters with our arguments, this is what the function is going to do. It's going to return this here. So when we call add nums and we replace a, b, and c, let's say 2, 4, and 6, this is saying, okay, so we want to replace a, b, and c with 2, 4, and 6, and we want to do this with the function. That's what we want to, that's what we want the function to do. And you can go ahead and run if you want. I'm not going to, but basically it's going to do 2 plus 4 plus 6, which is 12. And that's essentially what return is. It's an effective way to tell your function you want to do a specific thing when you call it. So for instance, I could say local function my text, and then I could say text as my variable, and I'll say return text. And when I set my argument, it's going to be the text. So let's say, hey Bob, and it's going to return whatever the text is, which means we're just returning the argument itself because we're substituting our argument with text for now, right? Because that's just the general form of the function, which is just text, and we're going to return whatever the text is, which means the function is just going to give us whatever text is, and whatever text is depends on the argument that you passed for text when you call the function, which is hey Bob. So this call is going to give me this text. So if I print that, it's just going to print, hey Bob, and you'll see here in a moment. So when I run, we just get hey Bob. Sorry, okay, hold up. I did not rename the function, so make sure you're using the name for your function. I just forgot to set it to the new name. So now it knows what function I'm talking about. And then it'll print, hey Bob, right there. Boom, there we go. Sorry for that. That was kind of sad on my part. But yeah, that's essentially return. So now we're just going to briefly talk about the difference between global scope and local scope. Let's define a local function, func1, and let's define another local function inside of that function called func2. And then we'll say print, hey Bob. So, oh, and believe it or not, guys, my name is not Bob, by the way. I don't know where I got the name Bob. I just use Bob for some reason. Like, I don't know where it came from. It's just what I like to use, okay? So if your name's Bob, hey Bob, how's your day going? But either way, the scope of this function, the second function here, is anything that is in the same block of code that func2 is in, which just means is it in the function? So if we call the function, so func1, we still don't really have a way to call func2 because it has a local scope. It's a local function, which means that function is restricted to the block of code that it's in. So if we're outside of this func1, we can't really use func2. But if we're in func1 and we go below func2, so now func2 is defined, and we say func2, we see it actually pops up here because it's in the same, it has the same scope. So if we actually called func1, it would actually run through all of this and it would say, okay, we got another function, and we're going to execute that function. Or sorry, we're going to call that function as a part of func1. So that's actually a third way that you can call a local function within another function. It's just to call the function after you define it. Because calling func1 is going to just run everything here. So if I run, it's going to print hey Bob. And there it is. Local scope just means the data type that you're defining is restricted to the block of code that it's in. Global scope, so any data type that does not have local next to it that you've defined, you can access it anywhere, no matter the block that it might have been defined in. So if I did this, and I got rid of this run that function, we can still call func2 because it has a global scope. But we can't do that when it's local, and you'll see that this func2 will turn red because it's no longer defined because it doesn't have the proper scope for us to be able to call it. So that's essentially what we talked about when it comes to local and global scope. So I hope that made sense. So, first question, let's create a function that when called will take three inputs, arguments, from three corresponding function parameters, and multiply all of them together and print the result in the output. So we're making a function, so let's do local function, and let's name it, well, what are we trying to do? Well, we're trying to multiply all three parameters together, and then print the result in the output. So let's just say do math, and we need three parameters. See, it says three corresponding function parameters, and it says we want to multiply all of them together and print the result in the output. So let's say, so we want to multiply all three of these parameters together so that when we enter all of the arguments, when we call the function, it's just going to multiply whatever those three are. So what we do is we do return A times B times C. That's basically what you do. So when we print, this is what the function's going to do when we call it. So when we call it do math, and we substitute for A, B, and C, we can do 2, we can do 8, and 5. So A is 2, B is 8, and C is 5. And when we call, this is what the function's going to do for us. So when we run it, it should be 2 times 8, which is 16, and 16 times 5, which is 50 plus 30, which is 80. So it should give us 80. And let's see. And we didn't print it. Okay, hold up. See, guys. Oh my goodness. All right. Yep. Whoopsie. Let's print it. And we get 80. There we go. So that that is basically the essence of that problem. Pretty easy. Just want to take three function parameters and we want three arguments that correspond to those parameters. And we want to just multiply all of them together and then print out the result in the output, which we did. So we have three arguments, three parameters, and we're multiplying all three of them together. And when we call the function, we're just going to return this, and that's what the function is going to do when we call it. Sorry, what the function is going to give us when we call it, which is just A times B times C. And whatever we put, we set them as our arguments. All right, so question 2. Create a function that when called will take one input from a corresponding function parameter, and the parameter represents the substitute for a brick color you are going to change on a part. So that when you call the function, the argument will be the string representing the brick color you're changing the part to. Okay, so apparently we're trying to change the brick color of a part, so let's insert a part. And the first thing we know is that we need to define that part, so let's do local part1 equals game dot workspace dot part. So now we've located this part. Let's create a function. So local function change color, because we know we want to change the brick color. And it says it's going to take a one argument. So when we call it, or that our argument, from a corresponding function parameter up here, and the parameter represents the substitute for a brick color you are going to change on a part, which is just part 1 in this case. So let's do part color. So that's what this parameter represents. Then let's click enter, so that when you call the function, the argument will be the string representing the brick color you're changing the part to. So let's just say part1 dot brick color equals brick color dot new part color, like so. Then let's call the function. So change color, and now we're actually going to pass the argument. So what's the part color? What color do we want to change it to? Let's say really red. Now let's run the game. And there we go. It worked. Okay, so in case you didn't understand that, let's break it down. So basically we define the part, and we want to create a function. It takes one input, so one argument, from a corresponding function parameter, and the parameter represents the substitute for a brick color you are going to change on a part, so that when you call the function, the argument will be the string representing the brick color you're changing the part to. So this is just the substitute for what we want to change the brick color to. And this is just going to set the brick color equal to this parameter, which when we call the function, we're going to run the function, but this time we're going to have the details that we need to run this code. And it's going to insert really red, because really red is what we replaced with the parameter. And that about wraps up question 2. So hopefully you understood that. Hopefully that made sense. Good job if you figured it out. But let's move on to the last question here. All right, so the last question, question 3, function A is inside another function B. Without using return, what other way can you run whatever's in function A successfully? Well, I'm already thinking there are 2 ways, but let me explain. So function A is inside function B. So let's define function B. Function B, boom. Okay, now we have a function A which is inside function B. So let's do local function A, and now we have function A. And it says, without using return, what way can we run whatever's in function A successfully? So let's just say print blah, 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 blah. And we want to be able to run function A without using return. So we can't say return A. We can't do that. So how do we do it? Well, there's 2 ways. Well, first we need to call function B to run function B. But we still can't run function A because it's local. It has a local scope. So we can't, it's not defined out here. How do we call it? Well, if you remember, there was another way that we could do it, and that's just to call A inside of the function. And that's going to run it. So when we run, we're going to get this print. It's going to work. There we go. We got the text, but there's a second way, which is to get rid of local. So this function is a global function, and it has a wider scope. We can use it wherever we want now. So let's go ahead and just get rid of A here. And now let's try doing A. And there it is, it appears. So now we can run it, even though it's restricted to B, but it's not, because it's global. So even though it's inside of function B, we can still use function A outside of the function. So those are the 2 ways you can call function A without returning the function call for A. Because the third way would just be to return A, which just means you're going to call function A when you call function B. That's essentially what you're going to do. So if we did this, it also does the same thing. But let's redefine it as a local function, and you'll see that when we run, this is the third way that we can run function A. So yeah, that is question B, 3. So that about does it for the recap. Now we're going to talk about conditional statements. And specifically, we're going to talk about what are called control structures. Control structures are basically statements that control what code gets run. So, I want to introduce something fairly straightforward. This is called what's called an if-then-else statement. And basically, if statements control whether code gets to run if a certain condition is met. So let's do this. So let's say local x equals 5. You know what that is. That's just a variable, x, which equals 5. Now let's say if x equals equals 5. So this is the unique syntax we use when we're going with if statements. And it basically just means if x equals 5. It's the same thing. But we use this unique syntax here where we do double equals. So remember to always use double equals. If you're trying to say that something is equal to something else, you use double equals. So if x equals 5, then, and it's going to open up this end. So basically this block is only going to run if this condition between if and then is met. So is x equal to 5? Well, yes it is. So let's say print x is equal to 5. So let's run. And this should run because x is 5. X is equal to 5. So now let's set x equal to 3. And let's run again. Let's see. Is it going to run? It didn't. Why not? Well, because the condition was that x equals 5, but x does not equal 5. It equals 3. So this only runs if x is equal to 5. So what if x doesn't equal 5, but we still want to print something? Well, we use what's called else. And else runs if our if statement does not run. So this is basically, okay, well, if this condition isn't met, we're just going to do this. So let's print x does not equal 5. Now let's run. It says x does not equal 5. So let me go over this again. So if this condition is met, then we're going to do whatever's in here. Else, so basically, if this condition is not met, however, we're going to do whatever's between else and end. And that's kind of the gist of it. So you see I have a part here. So I could apply this to basically anything. So let's say this part, let's say I'm trying to see if the part's brick color is a certain color or not, okay? So they say local part1 equals game dot workspace dot part. And I want to say if part1 dot brick color is equal to brick color dot new medium stone gray. So we should be able to, well, I guess not. Well, if it's equal to, if part1 dot brick color is equal to brick color dot new medium stone gray, then whatever is in here is going to run. So let's say print parts color is medium stone gray. Else print parts color is not medium stone gray. So if part1 dot brick color is equal to brick color dot new medium stone gray, which it is, then print parts color is medium stone gray. Else, so if it's not equal to medium stone gray, let's print parts color is not medium stone gray. So let's go ahead and run. And we should get the parts color is medium stone gray. Parts color is medium stone gray. But let's change the parts color to this green here, so lime green. Let's see what happens now when we run. And we get parts color is not medium stone gray. So that's what a conditional statement is in this case here. Now I want to introduce something called else if. So else if basically says, okay, well, if this isn't true, well, let's now check if this is true. So part1, let's say part1 dot brick color is equal to brick color dot new really red. Sorry, really red. Then let's just print parts color is really red. And we'll obviously put an exclamation there. And we'll do else print parts color is neither medium stone gray nor really red. And that's basically what an else if statement. It's an extension that says, okay, well, if and only if this condition is not true, this will run. So this will not run unless this first runs. So if part1 dot brick color is equal to medium stone gray, then we're going to print this. If it's not, we get our else if. So only if this condition is not met, this will run. So if the initial condition is not met, we go down to else if. So else if part1 dot brick color is equal to really red, then print, well, it isn't medium stone gray, but it is really red. So it's going to print parts color is really red. But if it's neither of those, then we're going to go to else. So else is kind of used as, well, if nothing else works, then we're just gonna do this. So let's set the parts color to medium stone gray. I don't remember where it is. Medium stone gray, here it is. Let's run. and it says parts of color is medium stone gray. So it worked. So now let's say that it's not medium stone gray, but it is really red. So let's run. We'll see parts color is really red. But let's say that the parts color is neither of those. Let's say it's new yellow. Let's run. Well, now it's going to print parts color is neither medium stone gray nor really red. So that is how conditional statements work. And there are some other things I'm not mentioning yet, but we're going to get into that. So we're going to start back at the basics here. So let's say local x equals 5. Let's say local y equals 10. There are some special words and or. So let's say if x is equal to 5 or y is equal to 2, then print one, at least one condition is true. So that basically means if this condition is true, or if this condition is true, then this will print. So both of them do not have to be true. Only one of them has to be true. If both of them are true, it doesn't matter. It's just going to print. If only one of them is true, it's still going to print. If none of them are true, then it will not print. So if x equals 5 or y equals 2, then this is going to run. So x is 5, y is 10. So one of the conditions is true, so it should run. And we'll get at least one condition is true. So let's go back and let's change x to 1. So if x is 1 or y is 2, then we're going to print this. But if neither of them are true, then this isn't going to run at all. So let's run. And we'll see that nothing prints because neither of the conditions are true. Now, the next word, and, means both conditions have to be true. So if I say and, so if x equals 1 and y equals 2, then we're going to print this. And we're going to change this message to both conditions are met. So would this run? No, because both conditions are not true. X is not equal to 1, it's equal to 5. Y is not equal to 2, it's equal to 10. But let's say that x is equal to 5 and x is equal to, or y is equal to 10. Both conditions are met in this case, so we should see this print. And there we go, both conditions are met. But if even one of them is wrong, so let's say x equals 3, which it isn't, equal to 3, this is not going to run. Because even though y is equal to 10 is true, this isn't. But because we have and, it means that both conditions must be true. If it was or, either or, so one of them has to be true. But if we have and, both of them have to be true. So now I'm just going to basically define all of the different operators. So operators are kind of like the symbols that you use. I'll just explain to you here really quickly. So let's say if x is greater than 5, then print both conditions we'll just say condition is met. Is x greater than 5? No, it's 5. If we did x is greater than or equal to 5, that's true because x is equal to 5. But if we just say it's greater than 5, it's any number that is more than 5. So this is wrong. This is going to run. The next one is less than. So is x less than 5? Well, no, it's equal to 5. If it's less than 5, it's any number below 5. But if we said less than or equal to 5, then yes, it would because x is equal to 5. Then the last symbol I want to show you is not equal to. So not equal to is this little squiggly, it's control, or sorry, it's shift and beside number 1 on your keyboard to the left of number 1, that right there, and you should get that squiggly line, and then you'll get equal. So this means not equal to. So if x is not equal to 5, then print. So if it's not equal 5, then this is going to print. But x is 5, so this isn't going to run. Because this is only going to run if x is not equal to 5. But x is 5, so it's not going to run. So those are, like, conditional statements are pretty straightforward. It's not really hard intuitively to understand how conditional statements work. So this is going to be a bit of a shorter episode, but I hope all that makes sense. Go practice. Oh yeah, I said every 5 episodes or so, a couple episodes ago, I said every 5 episodes or so, I'm going to do a quiz covering everything that we did from the previous 5 episodes. But I changed my mind. I think instead what I'm going to do is every 5 episodes, I'm going to make a project video where basically we're going to make a game that applies everything that we've learned in the past 5 episodes. I think that's what I'm going to do instead. Let me know if you guys want me to switch it up. That's what I'm going to do next episode. I think it'll be interesting. Because to be honest, we just did a quiz last episode, so I think a game is better because it's more. I'm showing you how I would code using the stuff that we learned. So that's a good learning opportunity for you. I think that's overall better for you for learning. So I think that's what we're gonna do. So next episode is going to be a project. And basically, we're just going to be applying everything we've learned to make a game. And of course, it'll be a small game. It won't be like a huge game. But either way, I hope you guys enjoyed this video. That's about it for this one. Once again, conditional statements are not that difficult. Pretty straightforward. Go mess around with them for a bit. We'll, of course, deal with them in our project. So I'll be talking about these even past the project. If statement, conditional statements are everywhere. You will see conditional statements everywhere in your scripting journey. So they're such a vital part of coding in general. But either way, that about wraps it up for this one. But until next time, I will see you guys later. Peace.
Alright, welcome back, y'all. Aversal here. Back with the sixth video. This one's going to be a little bit shorter, but we're still going to do the recap because this project is a little short. Like, there's not really a lot we can do right now. But I designed like a short little game that's pretty cool, and it just combines everything we've done up until this point. But of course, first we're going to recap. We talked about conditional statements, we talked about if statements, we talked about else statements, and we talked about else if statements. Then we covered some operators. So we covered greater than, less than, greater than or equal to, less than or equal to, not equal to, and you use two equal signs when you're defining a if statement. And then we just talked basically about conditions. And honestly, that's all basically for the recap. Like, once again, conditional statements are not that difficult to understand. They are just there to control the flow of your code, like what gets run and what doesn't. So if a certain condition is met, then do this. If it's not, we can say else if or we can say else. Else is kind of like the final option. If nothing works, then we're going to do this. Else if means, okay, well, the first thing didn't work. Now let's see if this works. If that doesn't work, let's do another else if. So we can do as many else ifs that we want. But remember, you don't have to include else if and you don't have to include else. It just depends on what you're doing and what you want. Yeah, but basically that was the recap. Once again, like this is gonna be a pretty short video, so this one's gonna be a little more lax. Um, I think you guys will like this a little bit more because it's not as difficult. um, but yeah, let's just get straight into it. So we're gonna make our little mini game here. So we're gonna insert a part first, and we're just gonna do that, and then we're gonna right click. We're gonna insert object. We're gonna go to script, and we're just gonna erase all this stuff. And the first thing we're going to do is we're going to define our part. So local part 1 equals, so there's actually a special word we can use to define workspace without using game, and it's just lowercase w workspace. And this is special because it applies specifically to the workspace. And the reason Roblox added this is because, well, we're going to be using the workspace a lot. So Roblox was like, okay, well, I'll just give you a shorthand way to refer to game.workspace. So workspace is basically game.workspace. This right here is basically the same thing as saying game.workspace, except it has a capital W because it's defining the service through the game. But this little shorthand way is workspace with a lowercase w. That's how we can just define it in more of a I want to save some time way. Okay, so it's the same thing. So workspace. So we're in the workspace. So dot part. All right, so we find our part. So now I'm going to show you what we're going to do. So I want to say I want to change the brick color of this part. So we're going to do local function change color. And we're not going to add any parameters, but we're going to define a variable called random color. And you're probably thinking, wait, we have not covered how to choose something random. And I'm going to show you how to choose a random brick color. Okay, there is a way you can choose a random brick color. And you do that by doing brick color dot random. So when you choose brick color dot new, that means in here you put the argument, which is the brick color that you want. But brick color dot random, you don't have to pass an argument because it chooses a random brick color. So the next thing we're going to do is we're going to print the random color. Sorry, the random color. And then we're going to return random color. So when we call this function, it's going to give us whatever this random color is, which is just brick color dot random. So let's go down and, sorry, we're not going to call the function right away. Actually, we're going to do part1 dot brick color is equal to, and then we're going to call a function. So here's why this works. Remember how I said when you call a function and you're returning, that means this is what it's going to give you when you call the function. So here's what the code is thinking. Okay, we're going to call this function, so let's go. So we define this variable, okay, sure. It wants us to print whatever random color is, okay. And then we want to return random color, which means that's what we want this call to give us. And remember, this random color isn't a parameter. It's actually defined as a random brick color. And this brick color.random gives us an actual random brick color. This isn't just a placeholder. This is an actual color. And it chooses the color at random every time you run the game. Then we're going to return whatever that brick color is, and it's going to return a string. So you're basically returning a string, which is brick color.random. Then we're going to say that part1.brickcolor equals change color. And what that does, it means when we call it, it's going to give us that string. And in this case, random color is just brick color.random. So you're basically saying part1.brickcolor equals brick color.random. And it's also going to print whatever that color is so we know what it is. We'll see it in the output. So let's go ahead and run. And let's just see what the output gives for us. So we'll see that the color is cool yellow, and you'll see that it is indeed cool yellow. So the next thing we're going to do is we're going to use a conditional statement. We're going to say if part1.brickcolor is not equal to brickcolor.new, and let's say really red, then we're going to print, well, the part's brick color is not, and then we did really red, so we're going to do RR. So let's change that. And then I do dot 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 to indicate that we're going to change it. So let's change it below this line. So let's say part1 dot brick color is equal to change color. Then we're going to print part1 dot brick color. Then we're going to say, okay, well, if it is actually equal to really red, because here we're saying if the part color is not equal to really red, then we're going to do all this. But let's say it is in fact really red. Then we're going to print, wow, the color is really red. So what are the chances that our color is actually really red? Well, it's really low. So let's run. And we'll see that it should give us 2. Okay, sorry. Actually, when you call change color, it also prints the color. So that's why we got pinecone twice. So you don't actually have to print it here. So let's go ahead and run this. And it should give us, well, it's going to get the first time, terracotta. Then we're going through that if statement, and it says parts color is not really red. Let's change that. So it changed it to dark orange this time. So terracotta was not really red, so it said, okay, well, it's not. So let's go to the else statement and let's do dark orange. Or sorry, let's go through with this. this block here because we don't do else unless the color actually is really red. And just to prove that, let's go ahead and do part1 dot brick color is equal to brick color dot new really red. Then if we run, you'll see, wow, the color is really red. And the only reason we see plum is because we called the function above here. Then we redefine the brick color before the conditional statement so that the conditional statement would still be met. So you see that it only says, wow, the color is really red, and it doesn't run any of this. It only runs the else statement because part1.brickColor is equal to really red, and therefore this condition is not true. Because this says that part1.brickColor is not equal to really red. Then we'll run this. But if it is equal to really red, then we're going to do this else statement. So I thought for this episode I'd just introduce this brickcolor.random function. It's pretty cool, it's pretty useful. And eventually we will be using this function to create a dance floor because you notice how dance floors are always changing colors. If you look at them, I'm going to show you how to use this to do that once we learn about something called a while loop. But either way, that about wraps up today's lesson, game, project, whatever. A little bit of a short episode, but I hope that was fun for you guys. Go try do some interesting stuff. Let me know what you've done with what you've learned in the past 5 episodes. But either way, that about wraps it up for this episode. And until next time, I will catch you guys later. Peace. What is good, everybody? Average Style back with, I believe, the 7th video in the scripting series. Now, in the video, if you notice that my voice sounds a little nasally, it's because unfortunately, I caught a particular illness that has been well known for the past few years. I'm assuming you can guess what illness that is. Um, but I don't want to talk about that because I can risk getting demonetized. But either way, I just wanted to let you know, just because if you're like, what's wrong with this guy's voice today? That's why. But either way, what's up, guys? Hope your day's going well. Hope your evening's going well. So you probably want to know, what are we talking about today? So today we're going to be talking about loops. And loops are very important because they basically allow us to run a specific block of code as many times as we specify. So I think we're going to talk about 2 types of loops for today. These are the loops I want to go over for today. So, oh, and they're called while loops and for loops. And those two are different kinds of loops, but they do essentially the same thing in the sense that they repeat a line of code a certain amount of times. But the difference is that one only runs under a certain condition, whereas the other runs a set amount of times that you make it run. And I'll get into all of that. And then also, we're going to talk about some basic data types. So, I have told you somewhat what data types are. You know that a number is a data type. You know that a string is a data type. You know that a Boolean is a data type. A function is a data type. But I'm going to explicitly define for you what a data type is, and we're going to talk about a special function made by Roblox that can tell us the data type of, let's say, a variable or something we write in our code, for instance, or something in our workspace or in any of our services here. I'll only briefly talk about that because a data type will become a lot clearer to you when you get some more experience with coding. But I just want to briefly understand it just so you get it kind of floating around in your head for a later video. Once again, this is a beginner's series. I don't expect that you to be a pro at everything I'm talking about just yet. But either way, let's dive right into it. So let's talk about loops. Let's go and let's just insert a script. Let's erase this print statement, this print function, and I'm actually going to prove to you that print is a function. But it should be clear to you that it is a function because of the open closing parentheses. That's the syntax for a function. But this is a special function because Roblox has already defined what this does for us. All we have to do is call it, and it handles everything for us. So we don't have to define print because it's already defined for us by Roblox. But either way, enough talk. So there are two types of loops I want to talk about: while loops and for loops. And let's talk about the syntax. So the first one, now, when I write this, please do not run your game. Okay, and I'm gonna tell you why not to run your game here in a second. But let's write while true do enter. So this is the first type of loop. The next one is for I equals 1, 5, let's say. Sorry about my voice once again. I'm sorry if I'm a little quiet in this episode. I can't really speak that well, but oh, also sorry, don't worry about that. I was just testing something. You'll learn what that means here in a bit. Oh, and also sorry for this. I was just testing stuff. But basically, let's talk about this first loop, okay? So remember, a block of code. So all of this loop, which you don't really know what is yet, I'm going to define it for you, is it's going, whatever's in here is going to be what's going to run when a condition is true. So what do you mean? Okay, so let's define a variable, and let's say local x equals 1, for instance. And let's say while x is less than 5, we're going to run this repeatedly. And we're going to say print x. This is actually going to run forever because x is not changing. So let's do something. Let's say x is equal to x plus 1. So every time this iterates, which means every time it goes over this block of code, and remember, it's a loop. So as long as this condition is true, this block of code will just keep running over and over again. And I should specifically mention that it runs extremely fast. And that is why I said not to run your game unless I say so. Or at least until you learn what just running a while loop does. Because it can crash your game. Because the code is running so fast that your computer just can't keep up with it. So we define a variable. While this condition is true, we're going to do x is equal to x plus 1. So we're going to first thing we're going to do is we're going to set x equal to itself plus 1. So x is going to increase. Then we're going to print x. Well, actually, let's go ahead and print x first, just so we don't get x equals 2 as our first argument, or as our first print statement. So while x is less than 5, do print x. So first thing it's going to print is 1. Then it's going to increase it by 1. Then x is going to be 2, but x is still not greater than or equal to 5, because essentially what x is less than 5 means is, well, if it's more than 5, if it's equal to or more than 5, this is not going to run. So what's going to happen is we're going to go x equals 1. Okay, let's do this code. Okay, we're in a loop, so x is plus equal to 1. Sorry, it's going to be equal to itself plus 1, so it's going to be 2. But this condition is still true, so it's going to keep going until it hits 4. Then it's going to go one more time, but then we're going to get back to the top, and it's going to say, wait, x is 5, which means this condition's not true. So how many times do you think this while loop is going to print x until it stops printing x? Well, let's see. Let's run. Let's see what it prints. 1, 2, 3, 4. And you're probably wondering, why doesn't it print 5? Well, let me explain. So let's go to when it enters the while loop. Okay, so it prints 1, then x is plus equal to 1. So it adds 1 to x, so now it's 2. We're going to print 2, we're going to add 1, print 3, add 1, print 4, add 1. But once it prints 4 and adds 1, now it's 5. So is this condition true anymore? No, it's not. So the reason it doesn't run on 5 is because as soon as it turns to 5 and it goes back up to the top, x is 5 now. So this isn't going to run. But if we said less than or equal to 5, then we'd get 5. And then it wouldn't do it anymore after that, because then it'd be greater than 5. It has to be less than or equal to 5. So, in a very basic sense, a while loop is a type of loop that constantly executes the same block of code from top to bottom over and over again until a condition is no longer met. And the condition is this. It can be whatever you want, as long as the condition returns true. And if you don't know what I mean by that, just think of it. Well, is x less than or equal to 5? If that's true, then it should just make sense that it would return true. If it's not less than or equal to 5, then it would just return false. Intuitively, that's all I really need you to think of it as for now. Understand that a condition returns true or false. And all that really means is this statement true and at what times? And at what times is it not true? And in that case, we're not going to do this anymore. Now, do not use this while loop. Like if you're following along and writing this down, do not do anything. We're going to come back and I'm going to define a very special function made by Roblox that can delay our code from running for a certain set period of time. So I'm gonna have like an applications part of our video for loops specifically because they're very useful. Um, Developers use them on the daily, but we're gonna do that in the applications part of the video. This is just the theory, and in the applications, I'm gonna introduce two keywords called continue and break. And also task.wait, which is the function I mentioned that basically delays your code from running for a certain period of time. So that, remember how I said while loops run very fast and it can crash your computer? Well, task.wait is actually going to prevent that code from running super fast. And we're going to get into that later. But for now, let's just talk briefly about what a for loop is. So, a for loop gives you a temporary variable and it sets it equal to an initial value, a final value, and there's a hidden third value which gives you the increment. So 2, let's say. Nobody, well, me personally, I never use this increment. I've never found myself using increments. But basically that means, okay, let me show you here. So we're going to get rid of all this stuff. So let's just print I. Remember how I said this is a temporary variable? This is a special variable only defined for the for loop. And I just means the number that we're on. So what's going to happen, let me get rid of this so it becomes more easier for now. I is going to start at 1. Then over the next iteration or next running of whatever's in the block of code, it's going to be I plus 1, then I plus 2, then I plus 3. So the first thing it's going to print is 1. Then it's going to print 2. Then it's going to print 3. Because by default, it increments by 1. But if you add, let's say, 2, then it's going to print 1. Then it's going to print 3. Then it's going to print 5. So let me do this without the increment first. So let's just run. And it goes from 1 to 5. And 1 is the initial value, and 5 is the final value. Now let's say increment by 2. So it's going to go 1, 3, 5. That just means how much we're increasing I by whenever we do an iteration. So run, and we get 1, 3, 5. Now let's say we do an iteration over a number that we can't reach. So 1 plus 3 is 4. 4 plus 3 is 7. So will this print 5? Well, no, because that's impossible. So it's only going to print 1 and 4. It is not going to print 5 or 3, 4, 7. It's not going to print 7 because the max value is 5. But either way, that's enough for increments. I don't use increments. If you've heard anyone that does or why it might be useful, let me know. Maybe I'm wrong, but I never personally use increments. But yeah, you notice how I can put I as a variable. into our print statement because you can use this variable anywhere. So it's really useful, and we'll see that it's actually particularly useful in what's called a table. But we're going to talk about tables in another episode. Now, one thing I do not recommend that you do is try to. So, remember how I said I is a variable? I don't recommend you ever try to change the value of I, um, because one, that's not particularly useful, but two, it might mess up your code. So do not attempt to change the value of I in your block here. All right, so now let's talk about applications. So let's go back to our while loop. Um, so while true do. And remember how I said, as long as this condition is true, this is just going to keep running over and over again. So let's say I had a part, and let's just say we have this part here. What was I saying? Oh yeah, so let's say I wanted the loop to change my brick color of this part to a random brick color every second. All right, so let's go to our script. Let's say while true do, and now I'm going to introduce this function. So I'm going to introduce briefly something called a library. So a library is just a set of special functions made by Roblox, of course. And that's all I'm really gonna explain them as for now. Right, I'm in a specific video. I'm gonna talk about all the libraries, but for now, just think of it like it's just a set of special functions that do specific things with your code. And one of the libraries I'm going to talk about today is called task. And you see it'll actually pop up here, task. Now, don't worry about what that means. I'm gonna talk about the task scheduler in another video as well. It's gonna be far in the future though. But for now, let's do dot. So the reason we use dot is because task is the library name. Now we're gonna go into the library and say the specific function we want to use. And in this case, we want to do wait. Now, don't worry about any of this gibberish. I'm going to talk about all this crap in a much later video. Once again, this stuff is too complicated. So all you should really know is just to memorize, for now, just the syntax. So task, which is the library, and then wait, which is the specific function that we want to use. Now, what goes into this for an argument? Okay, first it takes in one argument. So what is the argument? Well, it's in seconds. So you can see duration, number, right? In seconds, the amount of time you want to delay the code from running. For now, I'll explain it like that. So if I said 2 seconds, it's gonna go into this loop, and it's gonna say, okay, we gotta wait 2 seconds before we go below. So it's gonna wait 2 seconds, and then it says, okay, we waited, so let's go run this code again. Okay, let's go back up. Oh, we gotta wait 2 seconds again. Okay, let's run this after 2 seconds. So that's basically what it does. So let's say workspace dot part dot brick color equals brick color dot random. So here's what this is gonna do. Okay, we have a while loop. So when this is true, that means the condition is always going to be true. So when it comes to loops like this, when we don't have an actual condition, but it's always set to true, we have to use something called break. And break is basically going to force us to get out of the while loop once a certain condition is met, generally speaking. But you can also just do break like that. And what that does, it's going to say, okay, let's go into this and let's do task.wait2. So we're going to wait 2 seconds. We're going to change the brick color of this part. Then we're just going to break, which means we don't want to use this while loop anymore. Without break, let me just do this before we introduce break. So let's run, and you'll see that every 2 seconds, 1, 2, 1, 2. Maybe I'm not the best at counting, but it's about 2 seconds. It's 2 seconds. And you see that it changes it to a random brick color every time. So now let's say if it's a specific brick color, I want it to stop. So let's say if workspace dot part dot brick color is equal to brick color, sorry, equal to brick color dot new medium stone gray. There. Then we're gonna break, which means, okay, so this is always true, which means this while loop is always gonna run because there isn't really a condition, and the condition is always true, which means this while loop is always gonna run unless we break out of the while loop. So the first thing we're gonna do is we're gonna start from the top. Task.wait2, so we're gonna wait 2 seconds. Then we're gonna run all this code beneath it. Okay, so we're gonna change the parts brick color to a random brick color every iteration. Then we're going to go down and we're going to check this if condition, sorry, this conditional statement. So if the part's brick color is equal to a specific brick color, which we said was medium stone gray, then we're going to break out of this while loop. Now you might ask, well, wouldn't this be way too small of a time? Well, yeah, it is. So let's do 0.1. And you'll see that the brick color is going to change much faster. But remember, when the brick color is equal to this brick color, the while loop is not going to run anymore. So let's see if it does what we say. Boom. As soon as it turned medium stone gray, it broke. Let's do it again. That was pretty quick, by the way. Boom. We check medium stone gray. So it broke out of the loop. You notice how it just kept running over and over and over again. But as soon as this condition was met, we did break, which means the while loop is not going to run anymore. So specifically where your while loop doesn't have a specific condition that needs to be met, you're often going to use break to get out of it. So like let's say you only want the while loop at a specific time, then you can use break. But another way we could do it is, well, why if this is the condition here, couldn't we just replace this conditional statement and put the condition up here? And that's true. You can do that. So let's go ahead and run. Or sorry, I apologize. So I was confused for a second, but basically this while loop did not run initially because my brick color was already equal to medium stone gray. So I set it to medium stone gray, and this while loop is only gonna run ever if this part's brick color is not equal to medium stone gray. So the fact that my part was medium stone gray before I even went into the loop made it so that the while loop never ran to begin with. But when I started, I automatically changed the brick color first thing. So you gotta pay attention to that. My bad. All right, guys. So let's talk about continue. Now, continue is not usable in while loops, but they are usable in for loops. There's another type of loop called repeat until, but I don't think I've ever used a repeat loop. But if you still want to learn about it, it's called a repeat until loop, and it's fairly easy to pick up. Take you a couple minutes. But I'm going to go over the two that have been most useful to me. And they do pretty much everything you need. So I've never found an instance where I had to use a repeat loop. So yeah, but either way, so let me give you an example of how to use continue. So we're going to define a variable. We're going to say local. Actually, no, we don't need it because we're using a for loop. So we already have a variable, which is I. We're just going to go from I from 1 to 5 with a 1 increment because the default increment is 1. But once again, if you want to change it, you just add another comma and then you put whatever increment you want to do. So the next iteration, 1 is going to increase, which is our starting value, where it is going to increase by whatever your increment number is. So the next iteration, it would be 7. Either way, we're going to stick with 1. Once again, that's another thing I've never found myself doing is using the increment. But either way, so let's say if I equal to 3, then we're going to continue. But if it isn't that, well, we're going to print I. Now, what do you think this is going to do? Well, let's run the game. So, what's going to happen? Is it going to print 1 to 5? Well, let's see. 1, 2, 4, 5. It prints everything but 3. And you notice in that conditional statement we said if I is equal to 3, then we're going to continue. Now, continue is a special word that basically tells our for loop to just don't do anything below this if statement. We're gonna go back up and we're just gonna skip I equals 3, which is the third iteration. So we're just gonna skip everything that happens in the third iteration of this loop. So we're not gonna print I when I is equal to 3. That's what continue does. I have used continue a few times. I've definitely found points where I needed it. So this is a good one to remember. But honestly, break is a lot more important. But continue also has its purpose, of course, depending on what you're doing. So I think the last thing I wanted to talk about was what a data type is. And in a basic sense, a data type is the specific type of language that you can use in code. For instance, a function is a data type. A variable is not a data type because a variable's data type is just the data type of the thing that it's equal to. So if I said local number equals 5, this variable would just be a number data type. So now let's see how to check the data type of something. So let's say I have a local number, and also I'm going to define it as a num, just so you can see what I mean here. So let's say it's equal to 254. I don't know. So we're going to use a special function called type of. And type of allows us to put in a variable or just something we want to check the data type of. So in this case, we want to check the data type of a variable called num. And it's going to print it out. Well, actually, sorry, we do have to print it out here. Whoopsie. So we're going to print out the type of num. Let's run. It's a number. So that is the data type of this variable. So for instance, if I did text and I did Bob, I don't know. I just, hey man, Bob is just someone I can fall back on, guys. Okay, having a tough day. My boy Bob is always there for me, man. I don't know. It's just the first thing that pops in my head. Anyways, type of text, and it returns a string. So we talked about strings. That is a string. That is the data type. So a string is also a data type. And you get the process. So if we did text is equal to a Boolean, um, you can try this out yourself. It'll return a Boolean. A Boolean is a data type. If you set my func, and then we did function, oh yeah, I forgot to tell you guys, you can actually store a function into a variable. I never do this, but instead of naming the function, you just put the name of the function in the variable itself. And you also don't have to do local function because the variable is local. And then we could do whatever is in there, and then we can just print the data type that corresponds to this variable. And you could probably guess we're going to get a function. Now, there are so many more data types that I have not talked about, but that's for much later videos. For now, I just want to briefly introduce you to data types because, by now you've learned a little bit. So now, you're at that level where I can kind of get it into your head a little bit, what a data type is. You guys are good enough now where I can start actually introducing some of the theory. Now, if you're wondering if a while loop or a for loop is a data type, no, they are not. They're like if statements. They are called control structures. And they are not, for now, I just want you to think of it as they are not the data themselves, but they control how the data in your code flows, runs, does whatever it does. That's all they are. They're not data types, they're control structures. And you can actually, I'll link some stuff in the description because now you're at the level where I can actually start linking more advanced stuff to you if you want to learn what exactly data types and all that stuff are. Because by now you are at that level where you can start picking up theory. Don't go too far because there's going to be a lot of stuff you don't get. And I'm going to introduce that stuff slowly. But we're going to take our time with this. I'll give you links that I think you would be ready for. Yeah, but either way, um, that about does it for this video. Hope it was helpful. But until next time, I will see you guys later. Peace.
What's good, guys? Aversal here with the 8th tutorial in the scripting series, and today we're just going to talk about instances, how to create an instance, what that means, where that comes from. So yeah, look forward to that, but first thing, of course, we have to recap last episode. Last episode, we talked about loops. So if I insert a script and I make a while loop, so while true do. I can also make a for I equals 1 to 5, let's say, do. And all that means is as long as, for the while loop anyway, as long as this condition is true, which it is true always now because I set the condition to always be true, this is going to run. But it's only going to run, sorry, it's only going to stop running if we use a special word called break. Break basically just tells the loop to stop running. So I wanna print something. Let's print hello Bob. And then we want to break. So it's only gonna run this once. Otherwise, if we didn't have break, this would run just like a million times. Now for the I equals 1 to 5, I is a special variable defined specifically for this loop. And you have equals, and there's three special numbers. I only use the first two. But the first one means this is the value that I is going to start at. This is the value that I is going to end at. And the last value, which I'm not going to include, we talked about last video, is basically just the value that I increases by each time we iterate over the loop. But I thought I'd just tell you about that last one because maybe you could find it useful for something. We also talked about continue. So let's say I wanted to print I. However, I don't want to print the number 4, let's say. So if I equals 4, then let's go ahead and continue. So we're not going to run anything that is below this continue, and print is below continue. So as soon as we go from top to bottom, okay, we're going to go through this condition. Okay, is this true? Okay, well, when I equals 1, that is not the case. So it says, okay, let's skip over this. Let's go ahead and print I. And it does it for 2, it does it for 3. But once it hits 4, the first thing it checks, okay, is I equal to 4? Well, yeah, it is equal to 4. So let's continue. And what that's going to do is it's just going to bring it back up to the top and it's going to skip over that entire iteration. So anything underneath that continue that we were going to do before we hit continue. I'm just trying to remember what else we talked about when it came to loops. Oh, yes, yes, yes. So we talked about, right, well, we don't want this while loop to just run super fast because I told you if you run a while loop without any wait or any waiting period of time before we do the next iteration, it's just going to iterate through this loop millions and millions of times, and your computer's just not going to be able to keep up. So we use a special function called task.wait, and inside of these parentheses, we pass an argument which basically just yields the current thread, or in layman terms, it just stops from anything that's under this from running for a number of seconds that we put in here. So let's say 3, I put 3 in here, that means it's going to stop anything under here from running for 3 seconds. So yeah, I think that was all we talked about when it came to loops. Of course, this is very generalized, but that's generally the basis of it. So yeah, then the last thing, of course, we talked about were data types. And I really wanted to recap on this part because I made a lot of mistakes last episode when it came to data types. Understand that a variable is not a data type because all a variable is, it's a placeholder. It just holds this name. All this means is whatever it's equal to. A variable just represents the data type that it's named after. It's not a data type in and of itself. So when I say type of num, I'm just saying what is the data type that the variable num represents? Because I don't know if you guys read this in my, fact checking my errors, but a data type is just a value that you can store in a variable. So if you can't store it in a variable, it's not a data type. You can't store a conditional statement in a variable. It's not a data type. It's a control structure. Once again, you don't need to like fully take that to heart. Like, of course, this stuff takes time to really adapt to, but understand data types are just any value you can store in a variable. If you can store it in a variable, it's a data type. You can store any type of data in a variable. Yeah, but either way. But one thing I should note is, although you can't directly store a if statement in a variable, there is a way to bypass this, which is to define it in a function. So I said function condition, and let's go ahead and say, let's say look up my condition. Let's say, oh, sorry, yeah, right. Silly me. I'm so used to writing functions without variables, but and let's say if 2 plus 2 equals to 4, then print this statement is true. And then if we go ahead and, execute this, it's going to work fine, right? And there we go. But don't misunderstand. Functions are special because they can store so many different things, including conditional statements. Functions are, remember what I said, you can store pretty much any type of thing that you want done with code in a function because the purpose of a function is to do whatever you want as if it was normal code, just defined under a name. And you have to actually call the function for it to work. So functions are very unique, but I don't want to get into too much detail because it can get a little complicated. You don't really need to know too much about that. It's not really a big deal for now. But it's good to know more about how this stuff works later on. So we'll get to that eventually. But yeah, now that that's cleared up, we can go ahead and just say like local my var equals a string, and then we could just do type of my var, and my var just represents the data type that we're trying to find the type of. You get the point. But that was the main point I wanted to get across, is that a variable is not a data type. It stores data types. By the way, that wraps up last episode as far as I'm aware. I don't think I'm missing anything. So yeah, we're just going to go ahead and hop right into this today's lesson. So first I want you to notice these insert objects. And all of these things, remember how I said any of these things here you can just insert into any of your services here. Actually, I'm not sure if I said that, but basically these insert objects, these are all of the things that you can go ahead and insert into any of your services here. Now, some of them might not be useful in some services, some might be very useful in other services. Like, for instance, something you would put in the lighting might not be so useful in the workspace. So yeah, I'm not 100% sure if I have already gone over that or not, but basically that's the gist of it. Now, what have I told you? There's a way that you can insert any object you want into any of these services you want at any time in your script. And obviously for now we're just going to talk about the workspace because all of the other services, I mean, we're going to get to them eventually, okay? But for now, let's just keep focusing on the workspace. So there's this unique function called instance.new. And just like brickcolor.new makes a new brick color, and you choose in that string whatever brick color you want. Instance.new also gives you a choice of a string, and that's going to be any object you want. And these are your objects, right? Insert object, all that stuff. So just for now, I want you to just think of instance as an object. There's actually a more advanced definition of instances and objects, but that is not for the scope of these tutorials, okay? This is stuff you don't really need to know about until you get to that level and you're like, okay, you know what? Maybe I should learn about this stuff. It's just interesting to know. It's really cool to know. But either way, that's for another video. So you've been doing all this talk. Where is my instance.new? How do I make parts into my workspace, right? That's what you want to do. You want to insert a part into your workspace from your code. Okay, fine. I'll show you. Now first, we're going to define a variable. Then we're going to name the variable after the object we want to insert into our workspace or any other service if you're doing this in the future. But for now, we're going to focus on the workspace. So what is the object we want to insert? A part. So we'll say local part. We'll call it new part because it's a new part that's going to insert itself. Equals, and you might have heard me say it earlier, instance dot new. Then we insert a string, and it's going to give us the list of every object that we can insert into our game. So you had local script, you see all these things? It's the same thing that you see here in this list, insert object. It's all of these things. But it just gives us it in a nice clean list that we can scroll with. But we want part. Now, remember how I said you can go ahead and insert these new objects into any service you want? Well, how the heck is this script going to know my thoughts? How is it going to know what service to insert it into? Well, you have to define where it's going to go. So let's just say, well, new part dot parent is equal to workspace. So parent, this is a new word I haven't used up until now. I'm not sure if I told you guys like on a basic level what a parent is, but basically anything in this Explore tab that is within something else. So you notice how the base plate is in the workspace? That means the parent of this workspace, or sorry, of this base plate is the workspace. We go into lighting. This atmosphere object. So remember how I said anything you can insert into these services are called objects. So that's what I mean. Okay, for now, this is that's what it means. You'll get a better intuitive idea of what an object actually is and what it actually means in the case of everything here. But for now, you don't really need to get that. But yeah, this atmosphere object is the child of the parent, which is lighting. So let's take bloom and lighting. Which one is the parent? Lighting. Which one is the child? Bloom. So script. What is the script in? It's in the server script service. So the server script service is the parent of the script, and the script is the child of the server script service. I'm only briefly going to go over that because, I mean, by now you have a little bit of experience, and intuitively it should be a little easier for you to get something like that by now. So hopefully that makes sense. But yeah, back to this. We'll see if it works. So right now you can see we have no parts. Sorry, let me close these. We have no parts in the workspace. Like, well, we have the base plate and we have our spawn location, but we don't have any parts lying around. You can see it right here. I'm just gonna move this really quickly here. So keep an eye on this workspace, okay? So I'm gonna run the game. Boom. Look, part. It's there. It just appeared. But when we stop the game, now it's gone. So when the code runs, we get this part in our game. So yeah, that's basically the basis of an object. This is going to be a little bit of a shorter video. This is pretty straightforward. But yeah, you can go ahead, once again, you can insert any object you want. So I could insert, I don't know, a shirt into the workspace. And you won't see the shirt, obviously. It's just an object. You actually have to make the clothing yourself, I think. But yeah, you can see the object for this has been inserted into the game. And it's not a shirt, or yes it is, never mind. Shirt template. So yeah, it is a shirt. It's just called clothing, I guess. But either way, yeah, that about wraps it up for this video. I mean, there's not really much to talk about. Instance.new is just a special function that lets us insert any object that we can insert into our services, and we can express it as a variable, and then say, okay, well, we need to put it somewhere. So new part.parent equals workspace. And there we go. Now it knows where to put the part. Now you're probably wondering other things, like what about position? Like how do we position it? Where, like what if I want a part to be at a certain place? Well, we're gonna talk about that. But I'm thinking I'm going to introduce you to that when I feel it's the right time, which is soon. Don't get me wrong, but I have a lot of things I need to cover that are more important for now, and I think are more important for now. But yeah, I hope you guys enjoyed. That's gonna about wrap it up for this video. Hope you guys found it helpful. But until the next one, I will see you guys later. Peace.
Yo, what's good, people? Average Style here, back with the ninth video in the series. Yeah, today it's gonna be pretty exciting today. So last episode we talked about instance.new, was it? I think it was instance.new. And that's just a function that lets you, well, you know how you can do insert object, and you can insert an object into any service you want. And these objects are just all the things you can kind of insert into these services in your Explorer tab. And one of those is part, script. We've used those two objects. And I mean, that's pretty much all I want you to really understand about instance.new and creating new objects from your scripts. All right, recap over. So, the reason I want to keep this recap short is because this episode is going to be really special. Today, we're going to learn about events. And events are unique features of objects. So, let's say a part, for instance. Parts have their own unique events attached to them. So, let's say something happens to an object in the game. That's what we call an event. Okay, so that's what kind of the basic idea of what I want you to understand about what an event is for now. We're going to be talking about built-in events in this episode because those are the most basic form of events. And basically, built-in events are events that Roblox have added in for us. And all we need to know is the types of events that are attached to each object. Now, today I kind of want to just introduce the big first one that everyone kind of learns first when they're learning events, and that's the touched event. And what that means is, well, when this part is touched by another part, we're going to want to be able to know when that happens in our script, and we want to do something about it when this part gets touched. All right, enough talk. Let me show you here. So let's. Oh, that was the wrong object. Let's insert a script. Now let's go ahead and define our part. So let's just do local part equals workspace dot part. Now we're going to make a function to basically tell the game what to do when the event occurs. So let's say local function part touched. And the part we're talking about that got touched is this part here, which is workspace.part, which is right here. So when this part gets touched, we want to run whatever's in this block of code. So let's say I want part dot brick color to equal a random brick color. Then you're probably asking, well, just calling this function, you already know, well, this isn't really gonna do what I want it to do. How is it supposed to know that I want to only run this when the part's touched? And this is where events come in. Here's how you use an event. So first, you list the object that you want to connect, then you do dot, and now you're going to get a list of stuff, and that's going to include the events attached to that object. And in this case, it's workspace.part. And one of the events attached to that is touched. And touched, this purple lightning bolt, that's an event. So any symbol here you see with a purple lightning bolt is a event. And it says fires when a part touches another part as a result of physical movement. So part.touched. So the syntax seems pretty easy. So part is touched. Now what do we want to do when the part's touched? Well, we want to be able to connect this function, part touched, to when the game says, okay, this part was touched. So we're going to do some special syntax. We're going to do colon connect, and it says connects the given function to the event and returns blah, 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 blah. Don't worry about that. But basically, the point I want you to get is it connects a given function to the event that we're using, which is part.touched. We're going to connect a function into to this as a parameter. Sorry, as a argument. And our function is part touched. So go like this. Boom. Part.touched. Or sorry, part touched. Now we're not gonna run this yet because I want to get this part off the ground. And the reason I want to get it off the ground is because every time the part is touched, so let's say it's touched by this base plate, it's gonna change color, right? So that's what it means when it says it's gonna change the color of this part every time it's touched. And we're gonna anchor it since it's gonna be sitting in the air so that it's not touching any other part. Then we're gonna go ahead and load in. And yes, you can now change stuff in your game when you touch it. So look at this. Let's go. Yes, dude. Just changing the color of this part. Let's go. Congratulations, guys, like for making it this far. You spent a lot of time learning the code and you finally reached this point where you're starting to see some cool stuff happening. I hope you guys are enjoying the process. So one thing y'all might be wondering is it's changing the color so fast. How do I make it so that it only changes it? How do we make it so it doesn't run so fast? Because every time it touches, we can see that it changes colors like super fast. And that's because our body model has so many parts that are touching it at the same time. And it's going to be firing this event so fast. So this function is going to be running so many times per second. And that's not what we want. It doesn't look appealing. So I'm going to introduce something to you called the debounce. So I'm going to say local debounce equals false. And I want it so that this code is only going to run if my debounce is equal to false. So let's say if debounce equal to false, then, and we're going to copy and paste. So Control C, Control V. There we go. Then, okay, well now we're going to set it to true. And the reason I'm going to show you in a second why I want to set it to true immediately after I pass this conditional statement. Then we're going to say, well, what if debounce is equal to true? Well, then it's not going to do this statement. So we're going to say else. Well, what do we want to do if debounce is true? Well, we don't want the brick color to change. So let's return. And return is the same thing as in return. This is essentially the same thing as saying return nil. So nil basically just means nothing. It's literally nothing. Just picture like emptiness, nothing. And this is a special data type to represent when there is no value. So when we say return, we're just saying we want to just get out of this function. We don't want to run anything else. Because I'm going to show you why we don't want to run anything else. We don't want to run this task.wait 1 and then debounce equals true. And I'll here, let me show you here. So, or sorry, false. So let me show you how this works. So we set debounce equal to false, right? If debounce is false, then now we're going to set it to true. Then we're going to change the brick color. Then, well, we skip over this else and return because this is the first iteration of this function. Then we're going to have to wait 1, then debounce is false again, which means the next function call is going to be able to go through the same procedure over and over again. But let's say that you touch the part with multiple parts. There's just too many function calls. What's going to happen to the excess is it's going to go through, debounce is going to be true, and it's going to say, well, it's not false, so we can't do this code. So I guess we'll have to do else, return. Now, why is the return important? It's because if we don't put else return here, it's just going to skip the conditional statement and it's just going to wait 1 and then debounce is going to be false and then it's just going to keep spamming. I'll show you. So let's get rid of else return. Okay. So let's just do this. And let's go ahead and play. Let's see if it works without this else return. And we'll see that it stops for a second, but then it keeps fluctuating. And this is definitely not waiting 1 second before you can change the color again. And that's because we're not getting out of the function at any point. The calls are still valid. So what's happening is when we go to our script here, the first iteration of a function when we touch the object goes through. But then it gets called again and again because we're hitting it with multiple parts of our body. And it's just gonna go past this. It's gonna wait one, then it's gonna be false, and then it's gonna keep spamming. And it's just gonna make a mess. The reason we use else return is so that in the case that debounce is true, we're not going to get out of this conditional statement. We don't want any of this stuff to run unless we know for a fact that this stuff ran first. So it has to be the same iteration. So anything that isn't the same iteration, we have to say else return, because else return is going to run if we know debounce is true and this code didn't run on that iteration. Because if it did run on this iteration, all this stuff ran, then it wouldn't go to the else because the first condition was met. So it's only going to run this stuff. And then it's going to skip and it's going to run this stuff. We only want one iteration going at a time. So any iteration that we don't need, we're just going to return. It just means we don't want anything to be done. We're just going to return nothing. And we're just going to go to the next thing. And we're just going to wait for that first iteration to wait one and set it to false. Then the first thing that first one that gets in is going to be the next iteration. And then you have to wait one and everything else is going to be returned. It's basically a way of filtering out extra calls that we don't need. I hope that made sense. So let's go ahead and play. And you'll see it should wait the proper time now. There we go. 1, 2, 3, 4, 5, 6, 7, 8. Right, now it's waiting 1 second properly. So that's another unique way to use return. I hope that made sense. Just get used to using that. Once again, your return is really useful. I know it might be complicated as a beginner to understand how return works, but it's going to help you out in the long run. Try to get used to it, okay? Now, that's pretty much it. I mean, I only wanted to introduce the idea of an event. Once I get into, because we're getting near the end of the beginner series, I'm going to start the intermediate series, and that's going to go for a lot longer because in between beginner and advanced scripting, there's a lot in intermediate scripting. And intermediate scripting is going to be where you're going to learn mostly how to build a game, how to make a game, all of the useful stuff. This is just like getting used to the language, really. But once you get past this, then you're gonna really start learning useful stuff to make games. But anyways, let me stop rambling for now. Hope you guys enjoyed this episode. A little bit of a more applicable episode. You know, it's a little more fun. A little bit shorter too of an episode. Yeah, hope it helped. But as always, until the next one, I will catch you guys later. Peace. Yo, what's up, people? Welcome back to the 10th episode. Crazy. Double digits. It's crazy how far we've come. Good job on making it this far, y'all. So, what are we doing today? Well, firstly, we got to recap events, what we learned about events. Then we're going to talk about, for this episode, we're going to talk about in-game leader stats. You ever play a simulator? You saw those numbers at the top right? Those are your leader stats. We're going to talk about that in today's video after we recap events. So, first thing I'm going to do is I'm going to insert a part. We're doing the recap, by the way. So let's say I have workspace dot part dot touched. So that's a event attached to the part object. Colon connect function. So what am I doing here? Well, I'm making something that's called an anonymous function. So this syntax makes it so that you don't have to first define the function and then do the event call. You can do it all in the same thing. So just use the syntax that I did. So just do function, call it, and end, and it should have a right closing bracket on the right of the end. And then here it's just going to say, well, this function, this block of code is going to run whenever this touched event is fired. So this is what's called an anonymous function, and it kind of just combines the function call with the actual event statement here. So I use this method pretty often, but it depends on your needs. Just know there is another method of using events for objects. You can just attach the function, an anonymous function, which just means it doesn't have a name, right? And you don't need a name because it's specifically for the touched event. Hopefully that made sense. But basically, what I'm going to do is I'm going to do workspace dot part destroy. So colon, you notice how I did workspace dot part and then I did colon. So colon is going to let you call the methods of a particular object. In this case, it's workspace.part. So a method is just a function that is attached to a particular object. Well, for now, I'll let you think of it like that. But basically, part has a unique method or function attached to it that lets you destroy the part. So what do you think this is going to do? What do you think I'm trying to do here? Well, when workspace.part is touched, we're going to connect an anonymous function, so a function with no name, and we're going to say we're going to destroy workspace.part. And destroy is a method of this part object. So let's see what happens. Let's move it up, of course. I don't want the base plate to destroy it. And we're gonna go ahead and hit play and let's load in. All right. Let's go ahead and touch it. And let's look at our workspace, by the way. So you see part right here. Boom, gone. And don't worry about that error. There is a way to fix that error. It's basically what happened is, well, I believe what happened is it called the function multiple times, but this, like, let's say the second time it called, well, like, you can't destroy something that doesn't exist. So when you hit an object, remember that it's going to call it really fast, right? So don't worry about that error. This is just for the sake of example. But so yeah, that about does it for the recap. That's what an event is. You can use the touched event. There's plenty of events attached to each object that you have in your game. Try doing dot and scrolling down. Like let's say you insert a part, try doing dot next to the part and just seeing if you can find any purple lightning bolts and see what they do. That's a good way to learn events. You kind of just have to pick them up as you go. And you got to learn how to do that. So it's good to get practicing, guys. Either way, why not dive in? So let's dive in. All right. So we're actually going to be using the player's service today for the first time. We're going to be using a service other than Workspace. Believe it or not, crazy, scary, but I'm going to guide you. So let's do game.players. So we're referencing the player's service. Player added. So this player added event, this is an event, is unique to the player's service. And what that does is it says, okay, well, a player was added to the game. We can keep count of when a player joins the game. So let's connect an anonymous function. I'm just going to do that again. It should look like that. And you can pass one argument through this function, which is player. So we're going to say player, we can call it player, we can call it X, we can call it whatever we want. I'm going to call it player, but basically it's just the player in this service here. And I'm going to explain that to you in a bit here, but for now, let's print player dot name. And once again, I'm going to explain to you what all this means and where this is coming from. So let's go ahead and play. And what do you think it's going to do? Well, yeah, it's going to print man-eating plant 123, which is my name. That's my name. So how did it know player.name? Like, where is that coming from? Well, player means, okay, well, I'm going to go into the player service. While the game is running, you can see that my player is right here, right? You can see it. And then there's another me, which is my character model, the me that you can see that's in the workspace. But then there's the actual me, and that is in the player's service. This is actually me, and this is just the model that gets created when I join the game. And so when we say, oh, no, whoopsie, um, let me go to, hold on, don't worry about what I'm doing right now. Um, hold up. Um, yeah, so anyways, as I was saying, when we say player, what that means is just referring to this object here. This is what it's referring to. So just like a part, this is also an object here. And this object has a property called name. So player dot name. So Manning play 123. So player, this object, dot name, which is one of its properties. And the name says Manning play 123. So you can go through all of these properties. A lot of these are actually very useful properties. And they contain data and information about your actual player, your user ID, which becomes useful later on when we make simulators, and we want a way to have a unique reference to your player. Yeah, there's some interesting, unique properties. But you're probably wondering, what is in the player object? We have a backpack, we have player scripts, we have player GUI, player GUI. We're going to talk about a lot of that stuff. And we have starter gear. So, of course, you don't need to know what any of this stuff is yet. I'm going to talk about this stuff in the intermediate series. But let's go ahead and stop the game. So let's go to our script. How do we make a leader stat? Okay, so there's this very specific way that Roblox lets us make a leader stats system. And it's by inserting a folder with a very specific name into our player object. So remember player, that object of ours when we load in the game, and you see that Manny play 123 or whatever your name is. Well, I'm going to show you what that folder is and what it should be called. Now the variable name doesn't matter, but the name as a string does matter. So let me show you. So local leader stats equals instance.new. So we're going to make a new object, and we're going to call it, or sorry, the object we want is called a folder. And we want that leader stats, we want the parent to be equal to player. That means when we load in and well, actually, hold on. Let me show you an example. Let me show you how it works. So basically, leader stats dot name is equal to, and this is the most important part. Okay, I'm gonna explain all this stuff here in a minute. Just do what I do. Is equal to a lowercase l leader stats. It has to be this exact way. Okay, this is how Roblox is gonna know what you're trying to do. So let's start up. Play, and if you're if you've caught on to what I'm doing already, you're going to know that there's going to be a folder called leader stats in our player object. And there it is, leader stats. It wasn't there before, but it is now. So now Roblox knows, okay, well, whatever's in this folder, let's say like a int value, which I'm going to talk about here in a minute, is going to create an actual leaderboard right here. So let's actually do that now. Let's go to script. And how do we make a value? So let's say I want cash or something like that, right? Oh yeah, I also forgot to explain leaderstats.parent. So leaderstats.parent equals player. So remember the player object that we saw in the player service? If it's in, you saw that it was in the player, so it was the child of the player object. And player is the parent of leaderstats. Then we named it this exact name. It has to be this exact name. Now we're going to create below this a, let's say cash. um, currency. So we'll say instance.new, and we're going to do int value. So int value is a object, is instance.new, and then we do the object that we want. And int value just lets us store any integer. So that's an int value object. And you'll see that appear in the Leaderstats folder because we're going to do cache.parent equals Leaderstats. So we're going to put the cache, we're going to set the Leaderstats to be the parent of this cache int value. Then we're going to set cache.name, because we need to give it a name, it's equal to cache, because we can name it whatever we want now. This is the only thing we want to be very serious about. So now, congratulations. You've created your very first leaderboard. Vanity Plant 123. Cache 0. What does it look like? Players. Here's our player object. We have the leader stats folder object. We go into it and we see cache. Leader stats is indeed the parent of cache. You can see here. Cache.parent equals leader stats. Cache.name equals cache. Yeah, it is cache. So all this stuff makes sense. And it's the specific way that Roblox wants us to make this folder and all this stuff, to write the code, sorry, for this to work. So yeah, that's how you, in a very basic sense, make a leader stats system. And yes, of course, you can add more values, currencies, whatever. You just got to do the same process and set that value and then set its parent to leader stats. All of your currencies or your kills or your stage on an obby um, has to be childed to the leader stats. The leader stat has to be the parent, and the leader stats have to be in the player. So go ahead and try that out, guys. But yeah, that pretty much covers it for this video. Hope you guys learned a lot. Hope it's been fun. But until next time, I will see you later. Peace. Yo, what's good, everybody? So, today is the final episode I've decided for the scripting series. So, today we're just going to be doing a recap. And then we're going to make a game, a final project, that's going to reflect everything you've learned. Um, and I've decided it's just going to be a basic part's going to spawn in, and you can pick it up and you can get money. So yeah, that's gonna be basically what we do. And I wanted to prioritize the last 4 episodes, I think, because that's what we've done the most recently. But of course, the first 5 or so episodes, you should have those memorized, and you should understand everything I've said in those videos. Try to, as you go into the intermediate series in the future. But yeah, to recap last episode, we talked about leader stats. We learned that there is a service called the player service, and there's an event attached to that service called player added, and we can connect a function where one of the arguments that you can automatically pass when you call the event, or sorry, when you call the function attached to the event, one of the arguments you automatically get is the player object. So it's attached to each individual player when they join the game. So we can do whatever we want with that player object as long as we know the player joins the game. So that's a pretty useful thing. And yeah, we basically created a way of creating leader stats for the player, and we have to use a very specific name for the folder name, which is the leader stats folder. And then we can create values in that leader stats folder, and those are going to be our stats. And that's essentially all we talked about. Now I'm not going to give you an example because we're actually going to do an example in today's game. So this is going to be very hard. This is going to be the hardest thing we've done through the whole series. Trust me, because it's about 30 to 40 lines of code, which is new for you. I'm assuming you haven't coded that much, and even if you have, it's not this complex. So this is complex code, but it's basically going to let us spawn in a part as soon as we spawn in, but it's only going to spawn in one part at a time. And we can pick up that part to give us money each time a part spawns in. And remember, only one part can spawn in at a time. So I think it's about time. Let's start the final episode. So we're gonna go ahead and insert a script, of course. That's what we always do. Then I know automatically I want to create our leader stats. So player added connect function. Player is our argument we can pass through. Then we're going to say local leader stats. You can name this variable whatever you want. We're going to do instance.new folder, and we're going to do leader stats.parent equals player. So the leader stats folder is going to be in the player object when they join the game. And remember, this is going to be for any player that joins the game. And player is just going to be the player that joined the game. And so it can be any number of players. This code will always run for that player. And you have leader stats dot name equals, and then this is the specific part, so you have to specifically call it leader stats like that. Then we can define a stat, so let's do local cache equals instance.new int value, and let's say cache.parent equals leader stats. Let's say cache.name equals cache. And then we're done that. So now we want to define a function that's going to create a part, and it's going to regulate how many parts can spawn in. It's going to regulate how much money you can pick up from each part. And we're going to add something called debounce again. So maybe this will get you some better practice with debounce, because I know it can be a little confusing at first. So we're going to say local function create part, we'll call it. Then we're going to go down. We're going to say, well, make a while loop. We're going to say, and I'll show you why we need that later. But for now, let's say, okay, we're going to create the part. So what's the first thing we do? Well, we have to define the part. So local part equals instance.new part. Where do we put it? We put it in the workspace. There. It did it. Okay, great. So now we're going to define a boolean. I'm going to say local part active. So there is a part now. So when we run this function, a part exists. So now we need to know that this part is active. There's an active part in the workspace. So we're going to say true. Then we're going to say part.touched connect function hit. Okay, so I haven't talked about this. So hit, just like player added, has a built-in argument called player, and it refers to the player object in the player service. Part.touched, this event automatically passes an argument called, well, not called hit, but this is just what I set it as. But basically, it represents the individual part that touched the part. So now we're going to define player. Local player equals game dot players colon get player from character hit dot parent, and you're like, whoa, whoa, whoa. All right, so what is this? So get player from character is a method of the player's service, and what this means is we're going to get the player object from our character, which is in the workspace. And why is it hit.parent? Well, let me just disable this script here so that it doesn't run. Let's go ahead and play. I want to show you why it's hit.parent. Okay, I'm going to show you exactly why that is the case. So when we load in and our avatar is in the workspace, you can see that every part of us is its own individual part. But you notice that all the parts that are in us are all children of our character or our player model. And our player model is just known as our character. So let's say there's a part, imaginary part here, and I touch it. Any part that touches here, or that touches the other part, it's going to be that individual part. So let's say like right lower leg or something like that. It's just a child of our character. So hit, so let's say I Hold up. Where's my foot? Where do I find my foot? There it is. Okay, let's say my left foot hits the part. Well, we're gonna do hit dot parent. That's our character. Our right foot dot parent is just our character model. And that is what I mean when I connect this, and let's enable this script again. So disabling it just means it doesn't run when you run the game. So game.player is get player from character. This is a unique function in the player's service that lets you get the player object. So whatever's in here, it lets you refer to it. And we're talking the same player object that this talks about. So parent equals player. It's the same thing. The one that's in this player's service. So hit dot parent, remember? Let's say right foot, for instance, dot parent, get player from character. Well, this has to be our character model, right? See, right here. Hit dot parent would be the parent of the right foot, let's say. And that's the model. And if we have the character model, we can retrieve the player and we store it into a variable and we call it player. So now we have access to the player object. So now we're going to check because when the part is touched, we want to make sure that the part that is touching the part is our player. So we say if player is equal to nil, which means if there's nothing, there's no player, then we're just going to return. But down here, if we make it down here, then we know for a fact that it is a player. Well, if it is a player that touched it, then let's go ahead and do what we want to do, which is, all right, so the first thing we're going to do is we're going to destroy the part. So we're going to do part, destroy, then we're going to do player, and this is another reason we wanted to retrieve the player, so we can access player.leaderstats.cache.value equals the same thing, but equal plus equal to 1. So plus equal to just means player.leaderstats.cache.value equals player.leaderstats.cache.value plus 1. That this is the same thing, and I use this syntax over the other method, which is essentially just to do this. I'll write it out just so it makes sense for you guys. This right here is the same thing as writing plus equal to 1. It's the same thing. And the part's destroyed, which means is the part active anymore? No, it's not. So let's do part active equals false. And you're going to see where this comes in soon enough. So we're going to go down here, and we're going to say if part active, well, I should probably define this stuff out here. So let's say local part active equals false, because initially it's not going to be, but once we enter this function, then it's going to be true. So if part active is equal to false, then we're going to go ahead and execute the function because we only want create part to execute when there's no part in the workspace. Because remember, don't pay attention to all this gibberish. Just pay attention to this. We create a part, therefore a part is active. We destroy that part, therefore the part is not active. So if the part isn't active, then we're going to go ahead and keep running this function. So we only want this function to run when there's no part in the workspace. Now, if we keep checking this, spamming it, remember it's gonna destroy the game. So we need to wait, let's say 2 seconds. Okay. So it's gonna check if part active is equal to false every 2 seconds. So, looks like it looks like it'll work. Let's see. Let's see if it works. Oh, we got a part. Wait. No, that is not what we want. We only want one part at a time, remember? Well, if we pick them up though, we can see, oh, we got a bunch of money. And they spawn back in, you can see. But this isn't exactly what I want. Why am I getting a bunch of money from one part? It's because we don't have a debounce. And what happens when we don't have a debounce is it's going to blow through everything and it's just going to give us a crap ton of calls. So we only want one call to occur at a time. And how do we do that? Well, let's define debounce. Debounce equals false. Then we're going to say if part active equals false, so there's no part, and debounce is equal to false. Then we're going to go ahead and do that. So now where does this come into the function? Well, we're going to say if player equals nil or debounce is equal to true, then we're going to return. And basically that just means we're going to get out of this function on this call. And if that's not the case, then we're just going to do debounce equals true. And now let's see if this works. All right. Okay, so I'm back. Turns out the mistake I made was task.wait 2. Basically what happened is it just flew through all this code, but since there was no task.wait, it just automatically kept setting this stuff back to false, and so this function kept calling instantly after every 2 seconds, instead of waiting as it should until the first object is first destroyed and you get your money, blah, 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 blah. So let's go ahead and play it. Let's see if it works. Yes, it does, by the way. So we see one part comes into the workspace. What the heck? Where is it? It's in the center. Okay, yeah. Yeah, I forgot. It's gonna spawn in the center because that's just the default position that it spawns in. So let's just move the spawn location out of the way. And we'll see. It's right there. There it is. Okay, so cache 0, cache 1. Boom. Part. Inserts. Let's wait 2 seconds. Still no part. We step on it. Deletes. We get the money. Part comes back in. Get the money. Boom, boom, boom. Easy. That's what I'm talking about. So now I'm going to do a final recap, and we're just going to talk about everything, how this works. Pretty lengthy for you guys, especially. So basically, the first thing we did is we defined. I'm gonna copy and paste this code into the comments or somewhere in the description or something for you guys so that you can review this, try to understand it, try to break it down in your head. Um, yeah, but basically this block here, entire block, just creates our stats or our leader stats, whatever you want to call it. Then we're defining our controllers, if you want to call them that. Basically, it's going to control when this function can run, specifically because we've set it as a condition for the function to run, debounce and part active. Then we have the actual create part function. And then we have, so in this function, the first thing we want to do is we want to create a part and put it in the workspace. Then we want to say, okay, the part is active. Then we want to say, well, when is the part touched and by what? We define the player. We learn that there's a unique method in the player service called getPlayer from character, and you pass the character model into this parameter here, and it's hit.parent. Then we said if debounce is true or player is equal to nil, then we want to return. Because we know part is going to be touched at a lot of times, right? So we want to make sure that if any of this stuff happens, we want to make sure that the only stuff that passes through here is our player, right? And any other instance of a part touching the part is going to be ignored if there first isn't a player and second the debounce is true. Or sorry, if these conditions are met, then we're going to return. So if debounce is true or if there is no player, then we're going to go ahead and return. Then we're going to set debounce to true. So now we're assuming that debounce is false. And we're also going to assume that the player is not equal to nil, which means there is a player. So now we're going to set it to true. We're going to destroy the part, and we're going to add some money to the player leader stats. Then we're going to wait 2, and then we're going to go ahead and set debounce to false and part active to false. Then we define a while loop, which just means this function is going to keep calling over and over and over again in this separate little loop here. And we have a condition that debounce must be false and part active must be false. Then we're going to wait 2 because we don't want to spam the while loop. So we're going to wait 2 seconds and it's going to keep checking this condition. And if these conditions are eventually met, well, then we're going to call the function. So the reason we need debounce and part active is to regulate what calls of this touched function or this function in general are allowed to process any of this information here, right? Because it has to get past this condition, right? And as soon as we call this function, part active is true, which means that, well, we can't call it anymore because there's already a part, right? So part active equals false, then we're going to call this, but part active equals true as soon as we call it. So part active regulates the amount of parts that we can have because it's only going to call this function once at a time until it knows that part is no longer active, which only occurs after the part is destroyed, which means we can call the function again. And we wait a certain period of time so that stuff doesn't spawn in like immediately or our while loop doesn't crash. You get what I mean. You could wait like, I don't know, 1 second. This is just, it's gonna check every 1 second to see if these conditions are true. Task.wait2 just means, well, before we exit this function and all this stuff so that we can call it again, we want to make sure we wait 2 before we call this function because these conditions, once these are both false, then we can call the function again. So yeah, that's pretty much it. And obviously I'm going to define, I don't know, let's say function call loop, there, just like that. And we've defined everything we need to. So we got 4 main parts here. We got the function call loop, we got the function itself, then we got defining our controller, so what calls are going to get passed, and which ones are going to just return, or when is our function going to run, right? And then we have our stats, which we talked about last video. So that about does it, folks, for this, not just this episode, but for this series. Sadly. I hope you guys enjoyed the series. I hope you learned a lot. Yeah, I'm pretty excited to get into the intermediate series. Teach you guys a whole lot of new stuff, intermediate level coding. So it's going to be a lot harder, but it's going to include crucial information that you need to know in order to make your games. So yeah, I hope you guys enjoyed the series. And until next time, as always, I will see you later. Peace.